So can we start, Anupam? Great. Good evening, friends, and good morning to my other friends joining from other part of the world. Welcome to this webinar on Experts Conclave. It's going to be a long webinar, so get your coffee cups ready, and we're going to make it very interesting. We have a very accomplished faculty, mix of very senior surgeons, very young, enthusiastic surgeons, and we have some scientists in our group. Feel free to keep your questions, type your questions out, and we're going to use these questions as for the points for discussion. I'll be joined by my panel, Dr. Gaurav Rutra sir, Dr. Rishi Swaroop, Dr. Rajesh Fogla, and Dr. Rushad, and my team. So I welcome you all, and for all the mothers, wonderful mothers, a happy Mother's Day too. And I would like to start this meeting with Dr. Arthur Cummings. He is a very senior refractive cataract surgeon from Ireland. I've learned a lot when I started doing my refractive surgery. We used to have this, Gaurav knows about this, a lot of wave-light users know about it. They have this meeting once a year in different parts of the world. And I know we did not have any formal training in refractive surgery, no refractive fellowship as such. But I think 99% of what we learned is through these meetings. And Dr. Arthur Cummings is one of the people I always look upon as a great teacher, and I've learned a lot from him. Very fortunate that he's going to give his talks today. He has got 2 talks, and on ray tracing and PRK. I think we're all blessed to have him today. Dr. Gaurav, anything you want to say before we start with Dr. Cummings?
No, I think that was an appropriate introduction, Rohit. And yes, we've learned so much from him, right from the nomogram we use on the wavelight laser for the last almost 20 years. It comes from his clinic, and with his research and so much that we've learned all over the years. Nice to see you, Arthur, again.
Thank you so much, Rohit and Guru. That's so kind of you. It's an absolute pleasure to be here. I'm delighted that I can join you. Right, I'm going to start with speaking to you about ray tracing, LASIK, the early experience. I might just give this a second to load. I'm sure it's loaded now. So as I said, it's so nice to be part of this meeting. I'm thrilled. These are my financial disclosures. These are Alcon and Wavelight, really. And so just for reference, we've recently launched ray tracing as a new product. It's called Innovise, and it's a controlled launch in Europe currently. And so I'm going to share with you some of the ray tracing basics, which were from 10 years ago, and then something about what we've experienced now. So what's very important is 10 years ago, when the initial trial was done, patients had to be more than -4 or have astigmatism of more than 2 diopters. And all of these results were published way back. So just for background information is standard LASIK or wavefront optimized, aberration free, wavefront guided, topography guided, custom Q. It doesn't matter how sophisticated the diagnostics are, is once the laser has that information, when it wants to treat you, it believes that the eye that it's treating is Goldstrand's eye. And Goldstrand's eye has a cornea of 43 diopters and an axial length of 24 millimeters. Now, some of our newer protocols do take more corneal details into account, but they all accept that the eye's length is 24 millimeters, and they don't take things like anterior chamber depth into account. What made the difference all those years ago was when the Lenstar came around, and the Lenstar was licensed to Wavelight as the OB820, and at this wavelength, it actually saw the lens, so you could clearly see the lens. And because of this, you can now construct a virtual eye. And so now what happens with ray tracing profiles is instead of using a refraction, you use a wavefront. Instead of using the arbitrary 43 diopters, you use the shine fluid imaging for the anterior surface, also for the posterior surface and for AC depth. And then when you put the Lenstar on, you now get those exact interfaces, and you can now design a virtual eye. And now the treatment profile, the shot profile, is based on your eye rather than Goldstrand's eye. And if you see on top, all of these issues are taken care of with ray tracing, where even with wavefront guided, there's certain parts of the equation that aren't available. So there are far more assumptions with treatments, and with ray tracing, the idea is to try and reduce these assumptions. What's very interesting is that it also includes the expected biomechanical response and the epithelial healing response. So these were the results looked like years ago. It was a multi-center trial, Theo Salem, Matthias Maas, myself. We had 111 eyes after 3 months. That's how long the study went. And I'm going to share the results very quickly. They're published, but the results were very predictable. Astigmatism was well controlled. For the first time, we saw patients doing 12.6 were at 1.6 uncorrected, where 0.9% were at that same level pre-op with their glasses on. The distribution was really good. The safety profile was incredible. This is the entire group with 48% gaining lines. And stability was also remarkable, the refractive stability. Tissue saving was sometimes you were saving, sometimes you weren't. So it's something that one has to look at. And if you looked at the refractive stability and compared this to what was in the FDA studies, ray tracing actually outperformed the FDA study for the wavelight with wavefront optimized and with wavefront guided. If you looked at the same outcomes in terms of 20/20 uncorrected vision and mean sphere, you'd see that ray tracing wasn't quite as good. But remember, ray tracing was only -4 and higher astigmates. So when you extract those patients and now go and look at the wavefront submitted, the wavelight submitted data, in the -4 to -7 group, 80.8% with 20/20, 91 with wavefront guided, but 93 with ray tracing. In the group over -7, even in the FDA study, whose results are normally amazing, 70.6 with 20/20, with ray tracing, this went up to 90. So it simply increased the results. Looking at my own clinic, and when I looked at my data and I went and made it -4 and higher, with wavefront optimized, we see 16% gaining a line, wavefront guided maybe 19 to 23% gaining a line, custom Q, same sort of thing, just above 20% gaining a line. This is topography guided before we started using TMR or hybrid or forcities, so not very impressive, but the results with my cohort of patients, something like 70 patients, a huge increase in the number of patients gaining lines. So way back then, we knew that for ray tracing, it did improve the results if you were more than -4, if your cornea was different to 43 diopters. But now the question was, how is this going to fare when it's all comers, when it's patients of -1 and -2? And that's what the controlled launch was about. I'm just going to share this little video with you that shows you how we go through the process. Can you hear my sound at all?
Yes, Arthur, we can hear you.
But we can't hear your audio on the, if you have an audio on this video, we can't.
I'll talk it over. So this is on the portal software, looking at the wavefronts, higher order profile. We've taken out the one we don't like. So that's the wavefront approved. Now we're going to go and look at the topography, and we're going to see that they're fine. They all look pretty good. We can then go and look at the posterior topography, make sure that they're all fine. So we approve them. And then we go and look at the biometry. And all of these measurements are done off one device now. 10 years ago, 3 different devices, but today it's done off one device. So we can make sure the A scan is correct. And then what happens now is the calculation gets made. And so the calculation starts down the bottom. 10 years ago, this took 6 hours. Today, it's in between 20 and 30 seconds. So it's an amazing, powerful tool now, and one that from a user point of view is really, really fantastic. And you can now go and compare the results you have with Innovise versus topography guided versus whatever you want to do. Sorry, I just want to go to the next slide. There we are. So we had this controlled launch early 2020. There are 5 sites. Damien is one of them. And unfortunately, COVID has gone and messed up everything. And so we don't really have our 3-month data yet. And when I went and looked at our results, where we really did better than all the other profiles was after 3 months. That's when we looked at the data. So I was quite interested now to see that some of our results early on weren't amazing, but then it struck me, hang on a second, this profile takes into account epithelial remodeling and biomechanical changes, and that's why it's going to get better over time. So I went and looked at the Innovise data, which is the modern ray tracing, and compared it to what I got 10 years ago. And in fact, we're doing better with Innovise. But the 3-month data, I'm afraid I can't share much with you because we don't have that follow-up. I want to show you 1 or 2 examples. This is a patient who had previous surgery, wasn't in the study obviously, but I was just looking at how it works. So he's a minus 125 after previous surgery, and this is what his pure minus 125 profile would look like. This is what his contour would look like. This is what his oculink would look like, and this is what inner vise would look like. Now it looks a little different. So what's really important to remember is we mostly on these treatments, we remove tilt. But for inner vise or ray tracing, tilt is included. It's always included. You can't switch it off because that's how the original study was done. But if you now go and look at the higher order ablation profile specifically, this is what we're getting with the oculink. This is what we're getting with contour. And this is what we're getting with inner vise. So those of us who use these platforms frequently are always a lot more comfortable when we see that there's higher ablation profiles, when there's agreement. It just makes us feel we're more confident about what we're going to do. And yes, looking at the wavefront maps, they all look pretty equal. The topography maps are equal. Look at your A scans. You're happy they're good to go. There's one last case I'll show you. A patient who's 41 years old, had LASIK just about 2 years ago, and couldn't drive because of the glare. He was a -7, ended up at being +0.50 and +0.25, 1.3 vision, but the glare was an issue. This is what his correction would be just on wavefront optimized. This is what it looks like on Oculink. This is what it looks like on Contura. And that's what it looks like on Innovise. So altogether, a very good tool. Now, when you go back to Innovise, it's going to include the tilt. So you can look at the profile with tilt removed, but it's going to include tilt in the treatment. And this is also interesting. It's my very last slide. Is this patient had a similar prescription in both eyes. We treated the one eye with optimized. It's a -1, so it's 16 microns. Other eye is a -0.75, treating 30 microns, and that's exactly what I wanted to treat this patient. You sort of think treating 30 microns, you might be overcorrecting, but he came out absolutely perfect. So with Innovise, there's more data, there's less subjectivity, it's the ultimate personalization. It's just as simple to do as a wavefront optimized, given how easy the portal software is. Of course, we still need time to see the 3 and 6 month results to determine it is a better profile, but our early indications are very, very positive, and unfortunately, COVID has interrupted this as well as many other things. So thank you kindly for your attention.
Thank you, Dr. Arthur. Before we ask you questions, I'd like to welcome Dr. Nikki Hafezi. She is the CEO of Imaginize Zurich, and also board director of the Light Foundation. And they've been working extensively on many innovations and products. So she's here as a panelist to ask and give her ideas about innovations. So I would like to ask two questions to you. Then I think Dr. Gaurav is also wanting to ask. One is, first question is, once you have this, do you think that the whole Contura will be an outdated stuff? That do you think that we should still continue with Contura? Because you say that this takes in account of everything compared to Contura, which has to take in multiple or only one aspect of the optical system.
That's a very good question, Gaurav, Rohit. And I think that Contura is here to stay. It's not going to go away. And there are a number of reasons. Is you can't get measurements on everyone because it's measuring so many things and you don't want assumptions. We're getting about measurements on 75% of people. Another thing it does is it takes the wavefront undilated. So it's in a very, very dark room with a towel over your head, but it gets probably 75% of people measured. The second thing is there's additional cost, and it can only be done on the EX500. So Contura will definitely not go away.
Do you still need a nomogram? Are you building one more Wellington nomogram for this?
So that's very interesting. This is going to rely much less on a nomogram because it uses ray tracing to calculate on the eye, but you'll still have to have your personal settings because of your own humidity and temperature controls and your own technique.
Dr. Gaurav, you have any questions on this?
Yes, thanks, Rohit. Dr. Cummings, that seems very interesting, and I've been following this for the last 6 months or a year that you've been presenting. And I was keen to understand that as far as hardware goes, like what differences, if at all, may be required, and then how soon other centers may be able to start doing this, and what it takes to start on this.
So the whole idea was that as soon as the launch with the 5 centers was completed and everyone was happy that it's functioning well, and that would have been in June, but COVID has knocked that out by at least 3 months. And then it would be freely available. So way back 10 years ago, there were 3 different devices, the Pentacam, the OB820, and the Wavefront Analyzer. Now it's one device. It's an Oculus device licensed to Wavelight. Oculus called it the Wave, and it has a built-in Hartmann shack. It has a Scheinflug, and it has a barometer. And so the measurements are very, very straightforward of one device. The registration is really good. So as soon as it's been given the CE mark already, but the launch needs to be sure. You know, the moment you're marketing something as something better than what we had before, we've got to make sure that it is better than what we had before. So as soon as the 5 centers have collated data, we'll be in that position. So I think most centers are only opening up again in the next month or so, and then we need 3 months data. So we'll be looking at 4 months. Let's just put everything back.
Pooja, sorry. Yes, sir. Yes,
no, I'm good, yeah.
Pooja, any questions from the audience on this? Or anybody on the panel wants to add anything?
I have a question. Yes. What is the equipment you're using to capture the entire data in a few seconds? Is it the ANTERIOR?
No, it's a device that Oculus manufacture called the Pentacam AXL Wave, but it's licensed to Wavelight as a product called Sitemap. So it's a sitemap. It's a device you've got to acquire to do ray tracing.
Okay.
Any audience questions? Can we have anything, Dr. Pooja?
Just wanted to find out what about the role of assessing corneal biomechanics before you plan your treatment? Do you think that you did make a mention about it in your presentation? So
yeah, of course, you've got to make sure the patient's a good candidate. So that goes without saying. So these are patients who are good candidates. What the algorithm includes is epithelial remodeling as well as the expected biomechanical healing response. So it's a general number. It's much like we're doing for toric IOLs. We don't always measure the posterior surface, but we use Doug Koch's information and Graham Barrett's that help us take that into account on a global level rather than a specific one-to-one level.
I have a question for you. Can you hear me?
Yes, Dan.
You alluded to tilt and the fact that it was included. Can you specify a bit more about that?
Yes, as a Wavelight user, you'll know that we've always moved away from including tilt because it uses more tissue. But why it's been included here is because the original study way back when, in 2009, we didn't know. All we did is we gave them measurements. They were sent onto a portal in Zurich. The calculation was done and sent back, and we couldn't alter that. We just did the treatment, and the results were spectacular. But the treatment way back then included tilt. So for this first iteration of treatment, we wanted to have it as close as possible to the original. So it may be, with as it evolves, the tilt might be removed. Interestingly, for most treatments, it doesn't make a big difference. It might add 15 microns or so, and that makes us nervous because we think we're doing a bigger correction, but in fact, it lands up doing the same refractive correction.
I have a question. When you in the older machines, we always used to keep the tilt off. By chance, if we keep the tilt on, the machine would burn 50, 60, or 100 microns more. How do you think that this is different, that you're keeping the tilt here without creating more of a ablation burn?
So that's a super question. So in the past, we only had topographic data, and we were switching tilt on and off. Now, the tilt you're switching on and off is the tilt of the entire system. And it just goes to show that looking at something in isolation isn't always that good. Because if you had a lot of tilt in the cornea, you might find, in fact, your lens has some, but in the opposite direction. So often we see that the intraocular optics correct the anterior optics or vice versa.
Perfect. I think Dr. Pooja said I have asked all the audience questions. You have answered everything.
Rohit,
yes.
I had a quick question.
Yes.
It just came to mind as you guys were speaking. Which are the cases which will benefit the most from your new ray tracing treatments out there?
So that's such a good question. So way back when it was the -4s and the higher astigmats, the rollout is to figure out, does this have a benefit for everyone? Our feeling is it will have a benefit for everyone, but the person who's going to gain least is the one who anyway has a 43 diopter cornea and a 24 millimeter axial length. Then you're not going to get a huge improvement. But anyone who deviates from that should theoretically.
What about irregular corneas?
So the initial study is just on normal first-time eyes. But when we looked at it 9, 10 years ago, that's exactly who we thought would benefit. And so I've been doing it offline. I've always been looking at what these profiles look like, and they look very, very similar to what we're finding with topography and Scheimpflug. So I'm confident that it's going to help in those cases, especially with refractive predictability.
Great.
Farhad, a question for you. I know you've been using a lot of Schwinn-based system. Do you think that the ray tracing is something similar to what we are looking at the complete wavefront guided system of Schwinn? Do you think it's comparable to what InnoVice is? Would you like to give from your optical point of view, because you use a complete different system than what has been discussed here?
Yes, you're right. I've been using the Schwinn system now for 10 years, and I was on the Wavelight system for 9 years before. And I'm not at all into aberration research. So when I speak now, I speak rather from the standpoint of a refractive surgeon that uses therapeutic approaches. After all I've understood so far, I think this suit might make it much more comfortable for the user to get all the different options and possibilities just laid out in front of him. But I do know that I have all the possibilities on the Schwinn platform to do something similar, but it is not the same intuitive probably interface, it's not the same. I click right through it and then can compare. So it adds another level of ease to the whole procedure, which I think is very interesting. So in other words, I think if you take your race car and drive around the Nürburgring, I think the times will be similar, but you might have more comfort in this car for now.
Thank you. Let's move on to, you use the word aberration. The aberration, we've been hearing this from maybe 200, 300 years of different languages and different ways of how you study aberrations. I think we have a new way of studying aberrations. From all these years of work in refractive surgery, Zernike has come into our DNA in a very nice way, and it's very difficult to leave the Zernike out because everything revolves around Zernike. So Damien, like always, has tried to look out of box and decide that the Zernike is not the right way of assessing an aberration. And he, with his PhD last year in mathematics, derived a separate aberration profile, which he, according to him, and I'm sure I've read his papers, is going to be the real way of how the machines are going to use. So our children, when they become refractive surgeons, instead of Zernike, they will be looking at Gatinal polynomials. So Dr. Gatinal, up to you.
Thank you for this very optimistic introduction. It's a pleasure to be here and see your face, although I would prefer to interact with you all directly. I would go along your line and just say that this talk has one goal, two. One is to show you how Zernike are not doing what they should do for us ophthalmologists, and the second is to maybe convince you to move progressively to another approach, which we've developed, especially with my PhD thesis directors, Dr. Laurent Dumas and Jacques Mallet. And as has been said, yes, we are using, I have no financial interest, and to reassure some of you, there's only one slide with mathematical formulas, so please stay on. So yes, Zernikes have been, as you say, until now the gold standard, because what they provide us is a way to segregate between regular correction, regular astigmatism, defocus, that's called the low order aberration, and with spectacles we correct the second order one. And they segregate these aberrations with what's called the higher order, and that's what we called before irregular astigmatism. But using this classification, you can do interesting things such as predicting the point spread function or simulating the retinal image. But there's something which is important, is that it must be reliable and it must match somehow the way people see. And in fact, I'm going to show you that it doesn't really work the way we believe it is, and it's not really suited for relevant ophthalmic clinical interpretation and prediction, One reason is that these aberrations are coming from physics. They've been used in astronomy, and there's a long way from a telescope optics to physiological optics. Again, what is a low-order aberration? It's a quadratic function. It's the radial to the square here. And to make it very simple, in a myopic eye, when the wavefront exits from the fovea, it will converge to the punctum remotum. We've known that when we were doing elementary optical analysis of myopic eyes. So the wavefront, which is perpendicular to the ray propagation direction somehow, is going to be parabolic and steep in the center, and concave for myopia, convex for hyperopia, etc. Astigmatism, same system, but with a azimuthal dependence. And again, it's refined to a zero spherical equivalent. So it's like mixed astigmatism definition that we use in optics. That's for low aberration. Higher order aberration are something which is important, is that the wavefront distortions are in the periphery. So when you use a cubic or R to the fourth power, what you have in the cross section is a wavefront which is flat in the center, and where, for example, there's an asymmetric wavefront phase error here, or a symmetrical one, but in the periphery. And you see this, for example, after LASIK, or this would be in keratoconus patients. I'm going to show you an example. This is a case which we all had once and more than once. It's the patient who's 2020 or even 2015, but unhappy. And when you go with those patients through the aberrometry analysis, this is with the OPD scan and Zernike here, you find something which really doesn't match the clinical situation. The patient is 2015, but for high order aberration, that is, you correct the best, even if there's tenths of diopter, it's corrected, of defocus, it's corrected. You see, this is not really matching the visual performance of the patient. And when you look at the aberration chart, you find that tilt is very elevated. You find that there's a myopic defocus error very high. It's about 2 diopters of myopia, whereas there's no myopic error in that patient. And there's a lot of positive circular aberration. That's okay. It may explain the halo. But all the rest is not really echoing what it should do. And for those of you who've done some contura, presbyopia, we have those like funny compensation between C4, C12, in other words, between defocus and spherical aberration. This is the only slide with mathematics, but it's an important one. It just tells you that Zernikes, when they are called higher order, are not really purely higher order. They have low order terms embedded for reasons we'll not discuss here. But this is explaining the shape they have. For example, coma has tilt, is not flat really, it's tilted in the center. And more importantly, spherical aberration has a lot of defocus. It has as much defocus as it has force power in the mode itself. And again, that's why we have those irrelevancies. For example, this is a typical wavefront in a patient that had LASIK halo. It's flat in the center because there's no error there, but the optical zone was too narrow. So there's like a myopic error in the periphery only, and this is well modeled with the R to the fourth power wavefront aberration. So it's pure R to the fourth power. It's 1 micron for that example. What would this be in a Zernike expansion reconstruction? It would just be 1/16 micron, not 1 micron in R4, and you would have a irrelevant defocus error. Why that? Because you need to compensate this to make the wavefront flat in the center. This is why you have those myopic error, and it's not negligible at all. For 1 micron of pure R to the fourth power, you have half, even more than that, of false defocus in your reconstruction, and that's where this myopic defocus coefficient comes from. It's an artifact, let's say. It's to compensate, to balance the one which is introduced, parasiting, let's say, the fourth order Zernike aberration. And when it's even worse than that, when you now estimate the high order visual acuity of the patient, when you do the math, which is a Fourier transform here, you will take into account, because it's based on Zernike, the defocus, which is not there, but it will be in the computation, and it's blurring the image now. So again, it's been 20 years we are doing wrong simulation when we use those things with all aberrometers. Again, that's what's the problem with Zernike. It reduces the amount of circular aberration. It introduces artifactual defocus. The retinal prediction is wrong. and and again, this defocus creates unpredictable interactions with refraction. Okay, so in a nutshell, when you have positive spherical aberration, it has hidden hyperopia in it, and when it's negative, it contains hidden myopia, and the Zernike coefficients are minored 6 times approximately with regards to the true ortho component. I hope I gave you some food for thoughts about those Zernikes. Now, when you do corneal reconstruction, the same problem, if it's a hyperprolate in the context of Presby LASIK, you'll have again those interactions between the defocus, which is hidden in the Zernike. This will lead to inaccurate corneal power estimation. And when the cornea is hyperoblate, after LASIK, for example, you have the same problem of clinically inaccurate. And again, we are back to those compensation here that we have to do to make the defocus balanced when we play with C12. When we do Presby LASIK, usually we try to put myopia in the center and the wavefront is flat in the periphery. This is like a presbyopic profile of a non-dominant eye with near addition in the center of the pupil. Again, it's gonna be quick here, but when you use Zernikes, there's problem. Again, you can now feel what the problem is like. And when you use a dominant eye with the opposite pattern, again, with Zernike, you're not going to do a good job because of the defocus. So you're gonna under or overestimate defocus, you're not going to do a good job. And if you use another classification, it's gonna be better. For coma, it's the same problem, but with tilt. It may not have such bad kind of a consequence, but the same problem here. When you have a keratoconus patient, the wavefront is, which is good in terms of spherical correction, with spectacles correction, you will have a flat wavefront in the center. Because coma has tilt in it, you must compensate for the tilt, and that explains, and it's, 1 micron of pure cubic gives about 1 micron of artifactual tilt. This is why you have those tilt, which are usually echoing coma in a ratio of 3 times the Zernike coefficient of coma gives you about the tilt, artifactual tilt in the Zernike. So you have again listed here all the problems which are arising for those impure higher order Zernike modes. And it's even worse with high order astigmatism, because that is what should be a typical higher order astigmatism, that is astigmatism in the periphery of the pupil, nothing in the center. But here you see with Zernike it's becoming a mess because there's low order astigmatism in the high order one, which you need to compensate. So it's going to make your analysis quite difficult in the thing. So that's all the reason why we should move away from the Zernikes. And the bottom line is very important, is to improve the conception of customized correction. That's why we developed this new analysis. And at the first glance, you can see the difference is that the terms here, the modes are flat in the center. So they don't interact with the low order one, which are again pure in low order, and the higher order are pure in higher order. So a cubic function is pure, there's no tilt, there's no defocus in spherical aberration of the fourth order. And we have to pay one price, which is not important for clinicians, is a lack of orthogonality between the low and the high space, but that's really not important for most clinical reasons. We have a paper in GIRS with, again, a clinically friendly description of those modes, which are again flat in the center, which is very important. So they don't interfere much with defocus, and that's going to make our life easier for all those complicated astigmatism situation. It's been in a beta software, and I thank NIDEC to have implemented this, which makes my life simpler. Now I can compare immediately the two classifications, and that's what it gives. This is the previous example. You can see the difference. There was defocus, now defocus is low. Tilt has disappeared because tilt here was an artifact, and spherical aberration is not minimized. It was still visible here, but now it shows you what the true problem of the patient is. It's spherical aberration and coma, which was a bit, again, minored here for the same reason, which is now showing well. So, and again, that's an emmetropic eye with coma and spherical aberration. It's not an eye with a myopia and a bit of spherical aberration. Again, if you do the visual simulation, you will see things like the Zernike predicted sphere is wrong. The LD, low degree, H degree, high degree is okay. The realistic visual simulation is here, not there, because there's no defocus, and the point spread function here, computation is more realistic. Same case, you see the MTF is over exaggeratingly showing you a loss in contrast, which is not as pronounced here, but still there in the new classification. You can do the same thing with keratoconus patient, for example, compare the two classifications. Zernike one, it looks like a low and higher order problem. It's a bit maybe messy, a lot of tilt here, you see, 12 micron of tilt. But when you use the new classification, tilt has reduced, and you see better coma, you see better spherical aberration, which is negative. Wavefront is flat in the center, as should be, because it's a high order space here. And when you do visual simulation, that's a reference chart. This is Zernike, probably over-exaggerated for higher order. And now with the LDHD, it's less smeared and probably more realistic. The second ISM analysis, you see in Zernike, it's not really clear what the problem is. Whereas here you see coma popping well, spherical aberration here, again, flat in the center, which is as expected. And the visual simulation probably more realistic here in a patient who had a 20/20 vision here, whereas in Zernike, for the reason we've discussed, it's always a problem because you have defocus and low order astigmatism in the computation here, whereas this should be spectacle corrected as in the LDHD computation. This is showing you usually that when we do those experiences, we ask the patient to draw a letter, see how he sees with his spectacles. It's usually looking okay, similar, but the amount of smear is usually, because of the tilt, exaggerated with the Zernike compared to the LDHD. So in conclusion, I think this is a wavefront basis which has been made by and thought for ophthalmologists with expected benefits such as a better correlation with clinical refraction. I will show you later in my second talk. Increased clinical relevance, a better titration of higher order coefficients, which are minimized in the Zernike world. And this is, I think, a basis to better designs and anticipate the effect of the sphere and on the cylinder of customized correction. And on this, I thank you and all my co-authors.
Thank you. Thank you, Gatinel, on this. A quick question. When do you think this could be integrated into the laser machines? Are you working on something like this where this aberration profile, or you're just using it as a diagnostic tool?
So far, it's been like a diagnostic tool. Because again, when you correct for wavefront aberration, it's not really a matter of what you do in terms of classification. This is a way to interpret the wavefront. You don't have to reacquire. By the way, if you have the Zernike coefficient, you can immediately compute those. There's no need of doing iterative wavefront acquisition. What it provides us is something which is more straightforward. For example, when you play with the Q value of the cornea, you know, it's to manipulate spherical aberration. But when you do this with the Zernike, you not only manipulate spherical aberration, because as soon as you move spherical aberration in the Zernike world to another value, you move some defocus, which is embedded with. So you have to compensate it in a low order space, and it's not good. If you have a patient with a problem postoperatively, and you simulate the visual, because you want to retreat it with custom correction. If you do a visual simulation based on the Zernikes, you're not going to have a realistic thing. So for all these reasons, I think diagnostic is probably where they fit most. And hopefully also in a unifying kind of a philosophy, I hope that it will be kind of a universal approach for analyzing human eyes, or at least will be proposed in addition to Zernike to do better diagnostics.
Thank you. Thank you, Dr. Gatinel. I would like to move on to the next speaker. We'll keep the questions coming as we move on. Dr. Sheetal Brar, very good friend, fantastic researcher. She comes from Bangalore. She's a cataract refractive surgeon, and her main areas of interest is refractive surgery with SMILE. international trainer for SMILE for many upcoming SMILE surgeons. Today, she's going to discuss. See, what we have done is we have two very fundamental presentation, and after every two fundamental presentations, we're going into a case presentation so that it breaks the monotony. Dr. Sheetal, over to you.
Thank you so much, sir. Good evening, everyone. And I would like to thank Rohit, sir, for his kind invitation and giving me this opportunity to speak amongst the galaxy of stars in refractive surgery, both international as well as national, who all are participating in this webinar. So I'm going to discuss a very interesting case of a SMILE complication. So generally, SMILE is a very safe procedure and the results are great and patients are quite happy after the procedure. However, sometimes SMILE can become a frown and you can have unhappy patients, as was seen in this case. So this is a case of retained lenticules, retained lenticule in a patient. So retained lenticule or its fragments is considered to be a unique complication of a SMILE procedure because it never happens with LASIK or PRK, as we are ablating tissue in LASIK and PRK. However, in SMILE, we are extracting a thin lenticule from the cornea, and hence, therefore, there is a chance that it can retain in the pocket or it can get torn. So if the lenticule is retained or its fragments are retained, then it can lead to irregular astigmatism and an unaccepted visual outcome. So usually the causes for retained lenticules or fragments could be a lot of black spots or dense opaque bubble layer in the laser pattern, or the lenticule itself could be very thin and can get torn during the extraction. And if the surgeon is not familiar with the proper technique of dissection and handling of the tissue. So usually there will be a history of complication during the SMILE surgery, and the visual acuity would be affected. You have to do corneal topography. You can also do dilated clinical photography in retroillumination. And generally, ASOCT is a very useful tool which can give very useful clues about the location and the overall situation. What is happening in the case. So we have two approaches which can be used to surgically explore and remove these lenticules. First approach is going through the old or the original SMILE incision, and second approach is converting the SMILE cap into a flap. So you may have to sacrifice the SMILE cap and may have to convert it into flap procedure depending upon the situation. So what guides you to the decision making is, of course, the OCT findings, whether you see the lenticule sticking under the cap or is there a complete retention of the lenticule or the fragments are retained, or you have multiple planes or false planes. So this is one thing which can guide you. And second, of course, is the experience. You can always manage these cases with the PRK also. However, if it's a retained tissue and there is irregular astigmatism, then sometimes topo-guided PRK may not be a good choice. So since the source of astigmatism or the problem is the retained tissue, so we believe that the tissue should be extracted either by going through the same pocket or incision or converting it into a flap procedure. So coming to the case now, this case was a referred case from a colleague, and he performed SMILE on a 31-year-old female patient on both the eyes 2 weeks ago. Refraction in the right eye was -5 diopters, and in the left eye was -5.25 diopter sphere. There was a history of complicated procedure in the left eye. Right eye was uneventful. And as per the surgeon, there was a lot of difficulty in the dissection. He was able to dissect both the planes. So he said that he was able to dissect both the superficial as well as the deep planes. There was no problem with the plane identification apparently. However, he was not able to remove the tissue. So let us see what happened in the case. So we got the video of the surgery from the surgeon, and this was the surgery. So you can see that the laser pattern is pretty good. There are no black spots or opaque bubble layer or tissue or suction loss. But when you see the surgeon is trying to find the planes, he's having a difficulty here. So he's trying to identify the superficial and the deep planes, and he has got into some plane. Now, we are not sure which plane is this, but he's dissecting a plane here. And then he's going to the deeper plane. So most likely the surgeon thought that the previous plane was the anterior plane and he dissected it. And then the deeper plane is being dissected. But if you notice carefully, the surgeon is facing a lot of resistance here. Okay, so normally if the laser pattern is good, there was no problem. There should not be this much of a difficulty and resistance. But here you can see that the surgeon is struggling a lot, and there's a lot of manipulation going on here. And actually the video which we received was almost about for 45 minutes. This is an edited video. So he dissected 2 planes. And then in the end, he was not able to remove the lenticule. So he again took up the patient after a week's time once the cornea cleared, but still he was not able to remove the lenticule, and then he referred the case to us. So if you look at the topography, this was a topography at a presentation. In the right eye, it's a good topography. There's a nice central flattening. The uncorrected vision was 20/20 in the right eye. In the left eye, however, there's an irregular astigmatism. There was steepening in the center. Also, the pachymetry in the center was increased. There was edema. So the uncorrected vision was 20/60, and with a correction of -4 and -2 cylinder, it was improving to 20/20 partial. So this is what gave us very useful clues, the anterior segment OCT. So if you notice the OCT, you see the whole lenticule here, which is stuck under the cap. So it was not, so, and anyways, the surgeon has told that he was not able to remove the lenticule. So we could see the whole lenticule under the cap being stuck there. And under that, if you see this dark zone, there was also interface fluid under the cap and under the lenticule. And on both the sides, you can see there's another plane here, which is actually the false plane. So the true plane would be the posterior cut would be somewhere here under the lenticule and above the interface fluid. But you see there's a new plane, altogether new plane here, which is dissected at a depth of almost 300 microns, going from one side to the other side. So this was a completely new or the false plane which the surgeon had created, but he was not able to remove the lenticule. Why? Because the side cut did not come up to this depth. So we decided to use Circle software to manage this case. Again, the reasons were because there were multiple planes. If you see here, there are actually 3-4 planes where the surgeon has actually tried to enter. You have the original 2 planes, the anterior plane, the posterior plane, and also a false plane. And these planes were actually crisscrossing here, if you see here. So if you want to use the old incision, the smile incision, you may again end up going into the false plane again and again and cause more damage. So we decided to convert the cap into the flap using the Circle software, which is actually an off-label indication of Circle software. The approved indication is for enhancement after smile for residual refractive errors. So essentially, a Circle software converts the cap into the flap, and it creates 3 incisions. It creates a lamellar ring, a side cut with hinge, and a junctional cut, which joins with the old interface. So this is the surgery, repair surgery being done. So this is how the Circle software works. So this is a video of just the Circle software, just to show how it works. So this is the lamellar ring being created, followed by the side cut. And then you can lift the flap and go ahead with the ablations. So this video was just to show how Circle software is used for enhancement. So this is the actual video of repair of the case. Sorry. Yeah, this is the video. So Circle software already been used. And we used a nasal hinge in this case, because we do not want to interfere with the old incision, smile incision. And then we use the endo illuminator for better visualization of the edge of the lenticule. So once we lifted the flap, actually we could see that the whole lenticule was right there on the stromal bed. So Circle software is basically planned at the same depth of your original cap depth. So in this particular case, it was planned at 120. So we planned the Circle software flap thickness depth also at 120. So very carefully the lenticule was separated, and it was removed. So essentially, we converted the SMILE procedure into a flex procedure. Finally, the flap was washed and deposited. And this is the whole lenticle which has come out now. So 1 month post-op results, patient was very happy. Uncorrected vision recovered to 2020 and corrected vision improved to 2016 with the acceptance of minor cylinder. You can see in this sclerotic scatter photograph, there's some amount of scarring here. However, fortunately, it did not involve the visual axis. So we got very good results. And these are changes in the topography. This is pre-op and this is post-repair. Topography is returned to normal. And this is the OCT. You can still see the false plane. However, the lenticle has been removed and stromal edema has reduced. So in this way, we achieved very good result using Circle software in this case. So to conclude, Circle software could be a useful tool in complicated cases of SMILE. It facilitates easy access to the interface for exploration or topoguided treatments or PTK treatments if you want to do for an irregular interface, and it results in favorable outcomes in these cases. We have also published this case in Journal of Refractive Surgery last year in the January edition. So if you want to see the details of this case and how it was managed, you can always read this publication. So this was about this case, and I would like to hear comments and remarks from the panel about this case. If any of the SMILE surgeons have ever encountered this problem and how did they manage it? Thank you so much for your patient here.
Fantastic case, Sheetal. As usual, all your cases so beautifully managed, beautiful videos.
Thank you, sir.
Always pleasure to see them. I have one question, and I'll ask if Dr. Ritika is around. If she's in the group.
Yes, I'm there.
Yeah, she's again Dr. Ritika Sachdev comes from Delhi. She is part of one of India's biggest eye chain of hospitals.
Sheetal, can you switch off the presentation? Can you stop sharing it? Yeah, thanks.
She is also going to speak. She's a very accomplished SMILE surgeon. So would you do anything differently here, Dr. Ritika? I mean, I'm sure.
This case is actually complicated by various things, most importantly, the false passage. So therefore, I think the circle scan was a useful adjunct here. If you could just give me a moment, I'll just like to share my screen and show you if you can see this. This is just been recently accepted in JCRS. Okay. You also have cases which may be less complicated. So this is a lenticule which has been removed piecemeal. What we've used here is triamcinolone acetate. And you can see here that you can clearly delineate the edges of the lenticule. And this also helps you remove it. In this case, we did not have the complication of a false passage, so we knew that we could dissect it with greater ease. And we didn't need to convert to a circle scan.
So the take-home point is, before you go ahead and do anything,
you must do an OCT.
Yeah, anti-segment OCT is a must. I think it's a fantastic take-home point. And
in this case, it was a false passage, and it was at a much deeper depth.
Yes.
And there was no side cut at that depth. So
yes.
That's why he was not able to remove, and that's why the circle was very useful.
What was the cap thickness, Sheetal?
It was 120, sir.
Okay, because somehow from the OCT, I felt that the deeper plane was actually it was probably, I'm not sure, because, it was going all across right till the other end. And yes, the false plane was there. So what you did was absolutely right, because I think somewhere in between, he kind of, when there must have been dark spots or whatever, and, they did not have, and he forced his manipulator and made some plates.
What had happened was that actually there was no black spots. If you see the laser pattern was pretty good.
Was fine.
There were no OBL or any suction loss, but the surgeon did not find the planes correctly, and he dissected the deeper plane first. So when this happened, the lenticule got stuck under the cap, and he was not able to find the superficial. But because he was a beginner surgeon, it was his 4th or 5th case of SMILE of his life. So he was not aware that it was actually the deeper plane which he dissected. So in his mind, it was the superficial plane, and then he was digging under to find the deeper plane. And because the deeper cornea is a bit like softer and it's more easy to dissect, so he was, of course, feeling the dissection. The problem was there, but he was able to dissect it. So he thought that
But I think you managed it really well, Sheetal. Thanks.
But we didn't expect such a good outcome with this case. But
that's fantastic, and congrats on the paper also, both of you, you and Dr. Ritika. I mean, a lot of publication coming from both of you on smile-related research.
One point I wanted to make.
Yes, sir.
I don't do smile, but from a corneal surgeon point of view, Sheetal did mention about using the light pipe. So to look at all these corneal abnormalities, if you do a tangential illumination and you switch off your microscope light, you should be able to see these kind of retained lenticulae much better. And even clinically, if you say that the red reflex also helps you, maybe intraoperatively, if you keep your pupil dilated and try to look against the red reflex, you should be able to see the
I forgot to say, this case we have dilated the pupil.
And if you also have access to intraop OCT, maybe that would be another advantage, that where you can actually on the intraop OCT see where the abnormality is.
Yes.
Fantastic point. Use of intraop OCT and also using it as a dilated, using red reflex as a marker. I'd like to welcome Professor Santiago, Marconi Santiago from Brazil. He just joined. Can you hear us, sir? I think, anyway, I will go to his, probably there was some issue with his.
Yes, I can hear.
Okay.
Sorry, my phone was mute.
Thank you. Welcome.
Yes. Well, thank you. Actually,
so I will move on to my presentation. It's something which is interesting in today's world. You mute. Okay. Okay. So we are all, I'm not saying that we have all flattened the curve. I think curve is still on. I'm sure that curve is still going to be on for a long, long time to come. We just have to, now we have realized in the beginning when this corona hit the world, we all were putting up different posters in our Facebook, flatten the curve and everything will be all right. I think the reality has hit us hard that there's nothing called flattening the curve. It's going to go on. Maybe you can plateau it. So as we move on, this is a small presentation. Like I said, I'm trying to preach to anybody. This is just the practical difficulties I had when we started slowly getting back into refractive surgeries in this post-COVID times. So I call it as 3 Ps: prevention, precautions, and prayers. And that's how my presentation is. Like I said, there's a big disclaimer that I'm not perfect at this. It may be completely be wrong, everything what I say, because COVID makes us feel so insecure of whatever we say today, because tomorrow morning everything becomes obsolete. So when I talk about prevention, the first thing which comes to mind is all this. But the question is this the only thing we need when we start this? I don't want to get into this because all of us know what we are using and each one of us are using in our OT. One major thing when I talk about this is in this prevention aspect is the use of your conscious mind. I've realized in the last 2 or 3 weeks, I've realized that most of the time I was doing refractive surgery at a subconscious level, because you used to your tactile sensation, you are used to your mind working. You really hardly don't pay attention to so many things. For example, am I seeing an aerosol here? Am I seeing some fluid dropping from his eyes? What am I seeing? So my major prevention is use your conscious mind. So little bit on the conscious mind, most of us use the subconscious mind, which is based on a lot of things which you have heard, listened in our life, and very little of the logical and conscious mind if you don't see something new. That means refractive or cataract, any of the surgery has become quite routine. There's so many things in your mind which is happening all the time. You know, when you're doing the surgery, you're talking about somebody, or you want to go out or whatever, everything runs in your mind. That is and this is what is happening when you're operating. So because we already know, and when you're seeing a patient, you're thinking of so many other factors which runs into your conscious mind. So how do you really unlock it? So first precaution is be mindful in your OT. The first question is, what is mindful? We are always full with mind, not full. So lot of stuff happening out there. That means I've realized, I've been reading about this, I've practiced this form of meditation, but I realize the importance now when you start operating, whether you're a refractive or cataract surgeon, you direct your mind to the present moment. That means when I'm with the patient, what should I direct my mind into? And that is what is most important thing, not your PPE or your kind of N95 or gloves you wear. So what is important here is how aware you are, how much attention you are paying to everything. Is the fluid falling on my leg? Is there aerosols falling on myself? How close am I to the patient? How close am my assistant is close to the patient? Am I wearing the right glasses? Is my temperature right? And everything comes into the picture, which I probably never thought of. I'm sure, I mean, I may be the minority or majority here, but still. So there is a strong thing about scientific proof about how it works. And what I probably do is you have to sit and feel everything. You have to practice this and feel all these things what you have. And then your mind suddenly becomes into the conscious level. But otherwise, if you don't do this practice, I've realized you're always in the unconscious one. There are I'm going into this aspect of how I'm trying to bring this in my practice. But the most important thing is this is going to be discussed later in this conversation about when I go to surgery, is there anything I can do to protect myself for my ocular surface or wherever it's exposed? Chloroquine, again, hydroxychloroquine, again, is a question mark. So recently, this is something which we can discuss later. This is a beautiful paper for NEJM article about how the whole virus acts on the surface. We know that the corneal epithelial cells can also be, the same action can happen on the corneal epithelial cells, the conjunctival cells, any cell in the body, you can have this cell, the same thing. Endocytosis is a major phenomena. Chloroquine is one of the things. So we've been working on this research for some time about apart from chloroquine, is there anything else we can take to protect ourselves? One of the things which is very exciting is the role of trehalose. We have used this. There are lubricant-based, many companies make it. We use the trehalose inflammation. We use this for keratoconus. And there is this beautiful video about the cells. These are the corneal epithelial cells. And we have played this video many times. This is how the cells organelles work. And when the cells are in a lot of stress, this is what happens. And this is how the trehalose make these cells to regenerate itself. And this is something which we've been published and we have worked on it for many times. Now comes the most important thing, the role of trehalose in the viral COVID times. This is a picture. This is something which we have been working, and a lot of other groups in the world. You can see that a lot of other scientists from all over the world has worked on it. Basically, the trehalose has an action as in the early stage of viral entry into any of your cells. It is just like chloroquine. How the chloroquine here works on, how the chloroquine is working here, the same kind of place, this may also be working along with chloroquine because they have many functions on the ocular surface which are quite similar. This slide is something very exciting for us because this is the catapsin pathway. This is the pathway where it is working on a cell. Now, how does it make it important for me? It becomes a simple and a very effective. I'm optimistic. I believe in optimism of science. I may be wrong tomorrow, but for me, if there's nothing else, I would use it on myself every time I go into an OT. I have started doing it. Whether I get COVID or not, history will tell me. But look at this picture. The science cannot lie. And this is the pathway which is very important. So apart from this, after that, what do I do in my OT? A very well drape. Earlier, a lot of people have a habit of using a small drape. We use a very well drape so that it's covered completely. The whole eye is exposed. And this has become one of the most important thing of mindfulness for me. This is, we usually use whatever, wipe it and throw it off. Now I take a long time to dry my ocular surface every single step. My left hand is always having this sponge. I don't allow a single fluid accumulate in the ocular, in the whole cul-de-sac or the whole ocular surface, because anything there is a chance. Because if an AC is blowing or your air, whatever, it's a chance for the aerosol to come up. Socially distancing everybody off. I just want everybody to stand back. And we have a habit of keeping this here. I don't know how many of, after we do first, and the bed moves to the right side, I stop that. What do we do? Every time you discard, it could be for the smile also, could be for Sheetal when he's operating, we just discard it. I wash it with lysoformin or sodium hypochlorite solution, and then discard into your biodisposable bags. Again, I mentioned about drying. Use a lot of microscope, the TV, your monitor. I use very little of the eyepiece now, because I'm very close to the patient when I'm doing. So most of the time you can do everything through the monitor. You don't need a microscope except for, and the most important thing is this, how much I used to, earlier it used to be here. I think all of us are used to keeping it here. But every time, have you seen, there's always splash of fluid onto this. I have moved this out. I think I have moved this out because I feel if you keep this out, you avoid aerosol spill out into the thing. And post laser, again, washing, this is again, what I'm saying is most of the time I'm keeping at a distance from myself so that I'm very careful. This is what mindfulness is all about. Earlier, we never bothered about all this. We would just do the operation the way we want. And this is a typical example of where all it can get spilled and how this can change. And immediately after I do any procedure, before it goes to sterilization, again, it goes to lysoformin or any of the solution you like. And then you wash it, clean it, and then it goes to sterilization. So that this step, which was earlier directly sometimes used to go for this, has to be avoided. And rituals, I ensured that I re-scrub every time. I had to go back, and every time I use my gloves, again, wash it with, use the lysoform, use one of your alcohol-based solutions, so that, and we wait for 15 minutes, to clean everything after every patient, and then shift the next patient. So at the end of the day, I feel I'm terribly tired now, because there's so much of thinking has to be there so that you don't unnecessarily mess up on anything. And this is my next presentation. So I end my presentation here. I'm sure there'll be some debates, questions on this, and then we can go to the next presentation. Anything from anybody? Anybody wants to add? Ritika, Gaurav, Dr. Rajesh?
I have a doubt. I wonder if the plume evacuator, is it going to create a problem for us, or is it actually going to be helpful? I'm not sure.
The plume, I mean, if I speak from just from a scientific thing, it is heat. It's burnt out thing. So at that heat, you're looking at 42 degrees or 43 degrees. I mean, that I don't think any virus would survive. I think the problem with refractive is not your plume. Its problem with the refractive is your fluid. And fluids are the major. If you keep your ocular, I learned one thing. If you keep the surface and your whole cul-de-sac dry, I don't think there's going to be any problem on anything. The one which spills is your fluid.
So should we be avoiding surface procedures where we are doing mitomycin C and alcohol and doing a lot of washing?
Absolutely. Absolutely. So, I mean, with no financial interest or no extra love or affection to anybody, I think Smile has the least amount of aerosol spread at this point of time. We did some experiment with high definition, high speed photography to look for aerosols, and very minimal on it. And the microkeratome has pretty high level of aerosols. I'll be showing some videos of it in the few weeks coming, where we looked at how the aerosols are spilled over when you're doing a procedure. But mindful is every single time you take your suction ring, be careful that it is filled with fluid. We just usually take it out and throw it. All the fluid comes all over. We never look at it. If you use a very high-end, high-speed cameras, you will see how much of aerosols we are creating. So now what I do, even if you throw it, whatever you throw, just wash it once with hypochlorite or lysoformin, whatever antiviral it is, and then discard it into your tin, because everything can survive, because you usually take it at the end of the day.
Rohit, one question.
Yes, sir.
We know that betadine prep can disinfect the surface, even with the virus. So for LASIK or any refractive procedure that you do, if you apply the betadine, the topical 5% povidone iodine twice, I think that should sanitize the surface enough that when you're doing your surgery, the risk of contamination should be significantly lowered.
I have Dr. Arka here. He has around 18 years of experience on working on virus. He has a little difference of opinion on this particular virus with betadine. Arka, are you here?
No, the comment that I made comes from the Eye Bank Association of America, all the eye banks which are harvesting donor corneas. So they have looked at it, and the recommendations they've given for harvesting the donor corneas, that you do a double betadine prep, and then you can reduce the chances of having a contamination in your donor.
The only challenge, sir, is that many of this betadine preparation, the iodine-based ones, especially if they're still around in your ocular surface, we're only worried about how it create a reaction if there is, it mixes with your fluid, especially when you're washing the interface.
But we routinely use it for our intraocular surgical procedures when we do cataracts. So if it's safe, then I think it should be safe here as well.
Rajesh, we were typically avoiding using betadine inside the OT. Remember, I mean, what we've been taught right from the beginning is that do the kind of cleaning outside and let the betadine be out of the field as much as possible. I don't know. I mean, I don't remember reading, and you are a cornea surgeon, so you will obviously be knowing better. But for one of the things that we learned was to prevent in the days of DLK, we used to see that betadine was to be avoided in the eye. So I would be want to be doubly sure that betadine had no role. But since you are using it regularly, if you have experience with your LASIK and other patients there, but do you put a drop of betadine in the cul-de-sac just before surgery or wash it out thoroughly? Like, how do you do yourself? And if your experience shows nothing happens.
No, we haven't been using it. When we start, we want to use a drop of betadine. We can use it minutes before we take the patient into the laser room. And once the patient is prepped and everything, we can give it a nice thorough wash, and then we can start the surgery. So I feel that using a betadine prep should help reduce the risk of getting contamination.
I think it's a very good point. I think now that we are coming out with the new normals, I think this should also be one of the things which we need to figure out, whether use a diluted betadine. But for all the surgeons who are going to operate and worried about exposure, I mean, I don't know how much it's going to help, but a drop of one of this lubricant which has a disaccharide sugar definitely helps. In fact, we had put a grant to the government to make it like a spray, I mean, at some point of time, because it works exactly on a pathway which is chloroquine is blocking the whole the scatapsin pathway. It's a fantastic find. It should work. I mean, at some point.
I just had a question about chloroquine eye drops. Have you tried that as well, sir?
Chloroquine eye drops is good, but it's not a basic lubricant. It has it's an irritant, and I mean, if you have a choice, it would be the first choice. But there is certain limitations to it. But this is just a lubricant, and this is just an incidental find from certain papers which was published on the same subject. And I think at the end of the day, Dr. Arka or Swami, one of them will explain to you exactly how the pathway works.
Rahit, can you hear me?
Yes, sir.
Yeah, I would like to ask you a question. First, thank you very much for inviting me. I have lots of friends in India, you, Pooja, and everyone here. I saw that Abhijit is here too, Dr. Fogla, and also all my international friends, Dr. Gatnell, Dr. Hafezi, Dr. Kamis, and everyone there, Dr. Yoshida. So thank you very much for inviting me. To me, it's a great honor. Sorry that I'm super late here, but I have a question for you. You said you had, first, congratulations on your great presentation. I also saw Dr. Gatnell's presentation was also, as usual, very good. I missed the earliest one, so sorry. But let me ask you something. You said you have some super speed video with smile and showing the fluids and everything. So do you have, or have you seen any difference between transepithelium PRK and the mechanical removal PRK in this regard?
See, we have just started, like I said, I cannot really comment on this at this point of time. I will share some video once we accumulate everything. But I feel between the mechanical removal, which has more messier fluid, like Dr. Rishi said, with all that fluid washing and everything, transepithelial could be the better one. Like I'm saying, I'm trying to create more of hypothesis here. But of all the things which I see now, microkeratome should be causing more of dispersion of aerosols at this point of time.
But Roy, do you believe there's a lot of virus in the tear film, in the conjunctiva, or?
See, at this point of time, because we are not allowed to test every patient who is coming to you for refractive surgery, there is more of a scare that every single patient you're operating, we are assuming that he's a COVID patient. I'm completely wrong in this concept, but unfortunately, that's how it is. And even if you're able to test, the testing is not really done. And there's a lot of false positives, false negatives out here. So we really don't know. So what the best way to do is to assume that everybody is positive and treat it with that kind of
Yes. But even in positive COVID patients, do you believe that there's a true viral expression in the tears? I mean,
there's a chance around 2 or 3%. I think a lot of studies have been conducted on this now. We also started looking at some tear-based work on this COVID, and I believe that it can be even in a patient who's completely asymptomatic.
Okay. Do you put?
In fact, Rohit,
sir?
Do you put mask on?
There was this.
Yeah, we put mask on.
Today from Lancet, which has again looked at this possibility of transmission from tears, and it has again cautioned that we were beginning to think that it's probably not one of the routes which is very important. But I think it has cautioned again that this could be one of the important routes of transmission.
May I add something to this point regarding the virus and the ocular surface? Am I audible?
Yes.
Yes. So there is a very detailed tissue by tissue, organ by organ profiling was done, and corneal epithelium has been found to have the two major entry proteins expressed. So definitely entry through the ocular surface is proven. It's a risk. And the second question about viral load in the tears, there is only patchy reports are coming up. Maybe NN will do something more sustainable and very organized way of assessing it, because whatever is getting published about the viral load of the tears, if you look deeper into their methodology, is not very, very clean.
And I have a question for you, Swami, before we move to the next one, because you are the one who worked on this project on this the role of trehalose in as an antiviral prophylaxis. Can you just quickly tell how it prevents on the corneal epithelial cells and how it prevents a surgeon? If I'm using it, or tomorrow if Gatinal wants to use this lubricant when he goes to OT, how do you think it will help him or me?
Okay. Without mincing words, it'll prevent the viral entry into the patient's ocular cells. It will not kill the virus. It will only prevent the viral entry into the cells by, as you actually pointed out in your presentation, by blocking the endocytosis and fusion of the viral particle and the endosomal wall. So you rightly pointed out that.
So let's look at this hypothetical situation. Me and Gatinal and Dr. Gaurav are operating. There are a lot of aerosols. Let's assume that all of them are filled with some virus or something. And if we are using one of this, it protects us from, even though it latches onto our cells, it has a hypothetical factor which can protect us from entering in. Am I
Yes,
right?
absolutely. It's like a moat around a castle, and this trellis will remove the bridge out. So the virus will try to be there, but it will not enter the castle. It's something like that.
So Dr. Arthur has a question. The virus can found in tears, maybe 1 to 3% in COVID. What about the corneal stroma? Can it go through corneal stroma?
Right. So it depends on the infection status. So they are looking at tears. If you're looking at our tears, that means it can enter the cells. That's for sure. But how deeply it can go, it has not been verified. Only conjunctival epithelium and corneal epithelium has been studied. And the second thing is, it is going to be very invasive. It's the primary objective is to get the COVID patients all right, rather than going through a very invasive procedure to see how far the virus has spread.
But
Possibilities are yes, but there is no evidence.
But technically, it is difficult for the virus to go deep into stroma because stroma does not have epithelial kind of cells where it can work. It has to work on a keratocytes or one of these things. So it may be difficult for it because the epithelium is one which it loves.
Yeah.
It enjoys being there.
It enjoys being there to replicate. It's a perfect place for it to multiply.
So for all refractive surgeons, as long as your epithelium is intact, and if you're burning it off, or during refractive surgery, if you have a flap which you're lifting it and there's no epithelial disruption, I think you're still safe. Because during refractive surgery, you lift the flap, the epithelial disruption. I'm saying that I'm looking at every patient as COVID. That's a fear we all have, and I may not be the minority in here. I mean, all of you will be having the same fear when you operate on it, and that's what I said. Be very mindful about everything. And that's the most important thing. Be mindful of everything happening in your OT. I think that is going to what save us.
I have a small hypothetical setting. Would it be possible to create some sort of a drape which would cover the entire conjunctiva and leave only the limbus? And that may also be something which will create like a barrier.
I think, like you said, once you start going into OT, like I started doing now, you will see, if you're mindful, you'll see a lot of things which you would probably have never seen in the last 15, 20 years of your refractive surgery. You will see things which you got completely missed. And that is something which, you become Superman for some time because you start seeing with an X-ray vision all around.
So to add to that point, there is something called a rubber dam, which is used by dentists. So that is like an extended drape where you put a small slit and you can use a retractor to the right amount. That is like a drape for mucosal surface, rubber dam.
That's a question which Swami can answer. He says that the laser plume should be safe. Does the examiner kill the laser if it's present? It's heat.
I think so.
Should kill, but heat is...
I think I will leave it to the virologist. Arku Ghosh is there.
But I can answer it from what I've read. The heat induced on the corneal plane is 42 degrees during refractive surgery. The laser is known to survive up to 55 degrees. And in India, in many parts of India, even from where Ritika comes from, we're already at 40, 42. So if the virus is not killing anything at 42 degrees, I don't think it'll kill at 42 degrees on the stroma. A lot of work has been done. On the stroma, when you hit the laser, you induce heat only to 42 to 43 max. And I don't think that is killing the virus. Arka, quick comments before we move on. This is a very interesting topic. So I thought we'll have a little discussion because this is what makes this kind of meetings interesting.
Right. Yeah. So I think you're right that if the temperature is only 42 degrees, then that won't be sufficient. But that having been said, things that we can easily do and which you normally do in the OT should be sufficient protection. And like you pointed out, some of these eye drops, we can reduce the viral intake. So of course, all of these are temporary. So within a certain time limit, you'll be protected. So I think that's the simplest and the easiest way out. And if you just follow that, that should be sufficient.
Arko, there was a question about betadine as well.
Yeah, so betadine is used for adenoviral inactivation also, the iodine itself. And I think the betadine should work for coronaviruses also because it's essentially iodine. So it's a negative ion. So I think that should help destabilize the viral envelope.
Thank you. I think we'll move on to the next session. I know we are slow on time, but I don't want to rush through anything. I think most of you are sitting at home. So I'd already informed my colleagues to keep a coffee mug. I mean, this is a fantastic opportunity to learn from each one of you. I mean, this is what I think should be the way the meeting should be. I would like to invite Dr. Damien again to give his talk, second talk. Dr. Damien, are you ready?
Yes.
So he's going to speak on the machine learning and in perfecting outcome. I think this is very, very important today, is because the AI is coming everywhere. I think understanding machine learning is the way to go. So, Dr. Gatinal, up to you.
Thank you, Rohit, and thanks again for inviting me to this very exciting webinar. I would like again to thank all my co-authors because they all contribute almost equally to what I'm going to present to you now about what you said, the artificial intelligence, the machine learning. All these words are one of the biggest buzzwords of our time. And what I'm more specifically relating to in this talk is machine learning or deep learning, which is just like a kind of branch of AI. And AI is in itself a branch of, let's say, computer science. The surge in AI machine learning popularity arises from the explosion of data through mobile devices. Of course, we all know that computer power is cheaper, and at the same time, it's going faster and faster. And you see that in the old now iPhone 6, it was like 32,000 times faster than the Apollo era NASA computers, which took the man to the moon. And in medicine, of course, this surge is very present in healthcare because we can combine all the data we have now into those new resources that machine learning provides us. We have to, of course, create the conditions for that. But the idea is that we create programs from which we can learn, we can discover new things, and which is probably the most important aspect of what we do all day is to predict. And this is probably the most important slide because you have to change your paradigm. In the past, and that works, for example, for IOL calculation, you would start with data, you would use a formula, and the formula gives you an output, like the IOL power, for example. Or think about a nomogram. You enter your refraction, there's a nomogram, and you have an output. In all this new kind of approach now, you start with two things, the data and the known output from series you had before. And machine learning is to now invent or discover or rediscover the formula which combines all these data with the output. And that's how it works. So you need data a lot, output, quality output, and then you can guess the formula which connects these. So the prerequisites for developing machine learning in your place, I think there are three of them. The first is to have EMR, electronic medical records, because you need a lot of data, and this data must be conveyed to you in something you can exploit with softwares and computers. Second is lots of quality and pertinent data, and that's probably the most difficult part of it, is to make sure that the data you use is good. You know, we say garbage in, garbage out. So we are happy in ophthalmology because most of what we do is, of course, I'm speaking as an anterior segment surgeon, is more dealt with numbers than, let's say, images like we have in retina, because even a wavefront or a cornea is a image representation of number matrices that we have in the background of what we do. And the third and also very important thing, and I would like to thank these three fellows in particular, Alain Saad from, you know, Guillaume de Bellemanière and Pierre Zeboulon, who work with me, and you can see in their eyes how smart they are. And I will show you now what we developed together. So you need also to develop master programming language skills, which you can find in dedicated libraries. Python is probably the most popular. And what you start with in those kind of work is to clean the data again. You can have like thousands of biometry, cataract surgery records, and IOL implanted and post-op refraction. Even in EMR, it's not going to be written in the same way depending on the nomenclature you use, the surgeons, etc., etc. So you need to develop coding expertise so that at the end you have clean data sets that are really making the next steps possible. Again, you have a lot of open source algorithms online which are more or less easy to use, and there's a lot of resources you can find on the internet. So I will show you 3 examples of things we are developing. The first is using machine learning to develop new IOL power prediction formulas. Second is to try to see if, without explaining to a computer, this is keratoconus, this is normal, this is something else, can you classify cornea? This is called unsupervised machine learning. And the third thing is subjective refraction prediction using the new wavefront classification I alluded to in my previous talk. So first, for cataract surgery, as you know, what is difficult to predict is today the IOL position postoperatively once you remove the cataract, because you have to face many issues such as the change in the anterior chamber depth, the change in the volume of the lens, the IOL characteristics, which if you use a thick lens approach will be different even within the same IOL category because of the power change. Surgeon technique may also influence all these things. So that's kind of a perfect game field for machine learning, because on the other hand, we have, like in this example, almost 50,000 biometry variables plotted there from our database. And you see, you can all condense this in a kind of a vector with 6 biometry variables here: axial length, keratometry, chamber depth, lens thickness, wide CCT, and of course the post-op target, emetropia, slight myopia you want. And from these like 7 numbers, or kind of let's say 10 numbers total, you need a formula which gives you the IOL power. So what is important is, again, you will go probably faster to the result if these parameters are related. And when we plot them, the color is the anterior chamber depth. You see that there are relation between axial length and mean K with ACD. You also see that lens thickness is important, because if you combine lens thickness and axial length, you also see a kind of a segregation in the anterior chamber depth. But again, this is the pre-op, and it's going to be again influenced postoperatively by the surgery and the IOL. So if you want to do this thing, the pathway, the process is to start with the input, which is your known surgery outcome. So you go in your records and you can extract biometric data on patients you did surgery on and what they achieved in terms of refractive outcome using this or that IOL of this or that power. And this is, again, something you can do. And you can, again, process, again, these input in an optical formula, and you get an output. If you have the post-op refraction, and you can compare to the refractive target, you know how your formula is. But what is good now is that you start with real data. That is, in this patient, this formula gave this output. That's true. It's not something you bet. It's something true now. So using this, you can refine, of course, your formula, and this is what we do with the A constant or all the other constant. What you can do also is to use this as your database and as your training set. Now you have an input, which you know, and you know the output because you know what the patient refraction was. From these 2 important information, you can develop a machine learning formula that is a new algorithm with a merit function, which will be, for example, the minimization between the expected outcome, the predicted one, and the observed one. And you can also use part of your data to design test set, and that's important. It's the same thing. It's data sets which you don't use to create your algorithm, but which you use to test the versions of your algorithm to see how good they are. And that's the way you can evaluate your formula and refine it over time using this kind of loop. So again, what you start with is known outcome, and it needs to be of good quality, because if you have a poor refraction, in the file of your patient, it's gonna mess everything. So you need really to be meticulous in these things, like Rohit when he's doing a refractive surgery. And this is the first approach was developed by Warren Hill in the US with radial basis function. It's a neural network. And again, the input vector is biometry and refraction. And you have like a iterative adjustment of coefficient until you can, using known data, set coefficients so that it will work for new data with increased precision. Interestingly, in this formula, there's no optics. It's just 7 or 10 numbers in, 1 number out, which is the power to achieve the refraction. And from this, you can set neuron, which are in fact some kind of matrix calculation to get the result you want. We use the same philosophy, but with a bit of optics inside it. And we developed the PER DGS for the Bellmanier-Catinel-Saad formula to, again, work in that direction. It's based on many machine learning algorithms on a 10,000 eye training set. And the important features is that you can use it for post-refractive surgery patients. We have a special function for that. And if you know the outcome of your first operated eye in one patient, you can use this data. This is exactly the philosophy of machine learning. You learn from the left eye to improve the accuracy of the right eye. It's available online at the address at the bottom of the slide, iolsolver.com. And that's something we've submitted to publication, and we wait reviewers to send their revision. The second point is, so I told you, is automated corneal class prediction. We have had the orb scan for now 20 years in our institution. It's not maybe the best topograph, but still what is very good in machine learning, it's the best by far because we have probably more than 13,000 orb scanning examination. I just show you this number because these were the clean ones we could use with a kind of certainty. And interestingly, what we did in these things is we did not review all these orb scan maps. We just took 250 out of them. And we label only these like keratoconus, post-op, normal. Corneal experts did that. It's not difficult when you are a good corneal expert. But we did this out of 250 only. And then we developed algorithm based on the fact that, as I told you, a topography map, a pachymetry map, it's just number made visible for you to interpret them quickly. It's way more for our brain easier to interpret this and that. But for a computer, this is way more easier to interpret than this. And you can compare two maps as a computer by just calculating the distance, which is a Pythagorean kind of calculation. Each number is different here, but you can try to see what kind of cornea map looks like the other one. In other words, if you enter all these matrices, computers can evaluate the distance between these in a lot of dimensions. And again, what we've done is we didn't teach anything to the computer. We just extract 4 matrices for each map: elevation, anterior, posterior, curvature, and pachymetry. We entered those matrices and we asked the algorithm, which is a clustering one, to try to sort these corneas without any other instruction than minimize the distance between the map. And when we've done that, it was very interesting to see that we had clusters. But how do we know we do well? Because again, we had those 250 tracers that we can, for example, see. These are the data we know it's a normal cornea, and they are in the cloud here, in the blue cloud. So we know that the blue cloud is normal cornea. Then we illuminate the tracers for keratoconus, and we see that keratoconus have been automatically put on the side of this kind of a 3-dimensional cloud of corneas. Interestingly, the left and the right eye are also separated here, as you can see. Orange is right, sorry, and red is left. And again, that's something which is fascinating because this has been done on 1,000 cases without any instruction other than, can you find a way to segregate? So the clinical application should be something like, if you need, for example, for doing an algorithm to extract quickly 1,000 keratoconus maps, you can use this, and then you will get your 1,000 maps in a glimpse. You don't have to browse back in your data to extract them. You're going to have false positive, false negative. It's not going to be perfect, but at least you will have a bunch of data very quickly, again, because of this kind of unsupervised algorithm. And finally, maybe the core of what we do is to determine refraction. And we do it in a kind of, I wouldn't say crude way today, but it's very manual. We start with autorefractometry. We do subjective routine, which is like a kind of algorithm we use, like it is better like this or like that. And at the end, we find a prescription, which is another vector. It's 3 numbers here. That is the subjective refraction. Could we figure out something which from, let's say, aberrometry directly go to this thing? The good news is we have 1,000 cases that we refracted for who we have the wavefront that we acquired. For example, preoperative lazy candidates, they all have refraction, very careful one, plus they have OPD scan, for example. So we've used like those large numbers of patients that we classified using topography in different various subsets. And we could, again, as I said, it's important, you have training set and test set to develop something. I'm sorry, it's technical, but the idea is that you have the wavefront from the wavefront and the low degree with the new classification that I told you. You have a more reliable low degree than you have with the Zernike, because in the Zernike, remember, part of the low degree is hidden in the high degree. But here, with the new classification, we start with pure and comprehensive low degree estimation from which we can calculate those vectors, which are equivalent sphere and J naught and J45 astigmatism vectors. And we can compare what the wavefront prediction, which is mathematically calculated immediately, is compared to the subjective that a technician has done. And that's the first approach. How good is the wavefront estimation of the subjective refraction? Of course, you know it's not going to be perfect. How can you improve it? Again, what's important is that for a patient, not only the low degree can impact the retinal image, but of course the higher degree can as well. And it's important, again, you do it with the clean classification, because if you use Zernikes, you're going to have an introduction of low degree, which is hidden in a high degree. So you're going to mess up your work. You're going to say, oh, I want to investigate the high degree influence. But when you put spherical aberration, you introduce defocus. And I'm closing the parenthesis here, but think of all these kind of studies which were made on presbyopia, manipulating spherical aberration, which were made in some ways just by introducing myopia, not really pure spherical aberration. But here you can do that. So using these things, what we've done is we compared the subjective refraction, which was our gold standard. This is a reference with pure mathematical prediction from low order wavefront. And then from this, reanalyzed through machine learning using data we knew, and using also the influence of the HD. So in other words, we compare low degree with artificial intelligence, but no high degree, and low degree, high degree, and artificial intelligence to see if we can better predict from just an objective metric, wavefront analysis, on a 4 millimeter pupil, I must say, a 4.5, I'm sorry, what is a subjective refraction. And that's the last slide here, you can see. And we are happy to have this accepted in scientific reports. So basically, not surprisingly maybe, low degree this is the error here on the sphere, and this is the ellipse error for astigmatism prediction. So the higher the better, and the narrower the diameter, the better, of course. And not surprisingly, the best is to use low degree, high degree, and some machine learning. And what is a machine learning doing here is probably using high order influence to refine the prediction from pure mathematics or from pure mathematics and machine learning to better match subjective refraction. But what the most fascinating thing is to me is this on the right. It tells you what are the most important variables to predict refraction. And you can see, for example, for the sphere here, it's by far the sphere, the defocus from the wavefront. And secondly, spherical aberration, and we know that. But you see the relative influence of it is not that much. It's probably a quarter of diopters. In other words, We are doing this on normalized. I must tell you, if you take a post-LASIK eye, it's going to be completely different. But on normalized, you see, high order aberration do not influence much the sphere. For astigmatism, it's another story, you see. It's quite influencing. And even coma here influences a bit. You don't have to take this like metrics, absolute metrics. It's just a black box. We cannot say that it is influencing 20%, 10%. It's just like a ranking metric. But again, for astigmatism, high order astigmatism and coma are doing a kind of influence on the subjective refraction. Thank you very much for your attention, and I'm open to question. And again, thanks to all my co-authors for these works.
Thank you, Gatinal. What we'll do is we'll finish the next two speakers, and then because we'll add all the questions together, so it'll be easier. It's a great pleasure to introduce Professor Marconi Santiago from Brazil. Is wonderful human being, a great researcher. I think every day in every refractive clinic all over the world, his PTA is used, and I know he's given us one of the most useful and simple things to predict and see what is safe and what is not safe when you're doing a refractive surgery. Professor Santiago, are you ready?
Yeah, I'm ready. Can you guys hear me?
Absolutely. Perfect. We're all eager. Thank you.
Yeah, well, again, thank you very much, Rohit. To me, it's really a great honor to join you guys. You know, I'm a huge fan of all your work, the work you have been doing for like many years now, and it has helped us so much better understanding lots of things, you know. So thank you very much for all your contribution. And again, thank you very much for the invitation to be here today. Like I said before, I have lots of friends in India, and I happen to have very smart friends there. So I feel very grateful for that. Thank you very much also for Pooja for this invitation too. Again, congrats to Gatinal. He just gave another great presentation as well. So moving forward, not to be too late. So those are my financial disclosures here. And yes, today I'm going to speak briefly of all the research I have done related to PTA, and I mean now we are completing 11 years of research on this field. So I'll try to summarize it here. So recently, Dr. BJ Dubs and I published an editorial in JCRS where we tried to summarize the challenges related to the investigation of ectasia after excimer laser surgery. And we know ectasia most likely represent a reduction in biomechanical integrity below the threshold required to maintain corneal shape and curvature. But I will try to keep this presentation more associated to the fifth point here, the difference between risk factors and disease screening performance. We know the field of medicine is filled with examples of research that has elucidated the risk factors for developing complications, and an overlapping body of work that acts to develop screening strategies to identify undiagnosed disease. Unfortunately, these concepts get intertwined, or worse, interchanged, when in reality they are distinct entities that have different meanings, different methodologies, and serve different purposes. When interchanged, risk factors and screening methods are at best mispresented and misinterpreted, and at worst, investigated and presented inaccurately. Post-LASIK ectasia, as we all know, is a rare postoperative adverse condition, a complication by definition. And the fact that it's not a disease makes methodologically impossible to predict its occurrence. A risk factor is an aspect of personal behavior or lifestyle, environment exposure, inborn or inherited characteristic, which from epidemiological evidence is known to be associated with a health-related condition, considering essential to prevent. So to be associated, not to cause. This is very important. We know from the paper published from Dr. Seiler in 1998, the so-called limit related to residual stromal bed. The sentence that he had on that paper is exactly recommendation to keep the residual stromal bed of at least 250 microns. So I'm not going through everything related to that paper, but on summary, I just like to show this to highlight the most important point here. So 250 microns left as a residual stromal bed would mean a different change considering the flap plus the ablation depth. And everyone remembered this this number 250, and some people remember this paper, but not everyone remembered that to even consider that as a possible limit, we would have to assume, as he wrote in the paper, and everyone knows now at this point, we had to assume that the biomechanical parameters are constant throughout corneal thickness. And we know this is not true, until as the corneal tensile strength is not uniform throughout the central cornea, with a progressive weakening in the posterior 2/3. That's why, for us, on summary again, a percentage of the change seems reasonable to really understand the actual impact the excimer laser surgery had on that specific patient. So for LASIK, we proposed this combination of the flap thickness plus the ablation depth divided by the preoperative central corneal thickness, or the thinnest point if it's available. The point here is to have an available tool that you can calculate with your hands. You don't even need any device, and compared to residual stromal bed is more representative of the actual chain that occurs. So we started everything, investigated the chain that occur after LASIK eyes that had when they were submitted to myopic LASIK, and how those eyes would behave after the surgery. And then when we understand and we studied all the preoperative variables that were available, we saw that PTA was the variable that would related the most with the biomechanical chain that occurred after this procedure. So when we investigated the role of ablation depth, flap thickness, corneal thickness, residual stromal bed, everything, the PTA was the variable that impacted the most in the corneal weakening after normal eyes that were submitted to LASIK for myopia. Everything started there. Also, the PTA was the variable that impacted the most on the posterior bulge in those eyes after myopic ablation. We were not at that point investigated ectasia. We started investigating the impact after excimer laser ablation. Then we started to specifically investigate the role of PTA on eyes that had bilateral normal preoperative topography, placido-disc preoperative topography that ended up developing ectasia. And yes, I mean, on summary, we found that the ectasia case had on average a higher PTA value, but most importantly, we ended up finding out a cutoff, and using that cutoff, we found that an odds ratio that was higher than 1, that did not include 1 in the confidence interval, which by definition made it a risk factor for the adverse event of ectasia. Again, this is everything on summary here, just to summarize the results. So when we compare when we analyze the eyes with normal topography that did develop ectasia and saw the prevalence of other risk factors, especially the residual stromal bed, which is the direct comparison here, we saw that if you had used the residual stromal bed of 250 microns, we would have missed almost more than 90% of the eyes that did develop ectasia. And even if we had used the residual stromal bed of 300 microns, we would have missed more than 45% of the eyes. So those are eyes, again, that did develop ectasia that had we considered only the residual stromal bed, we would have gone ahead and had done surgery on those eyes. Again, one of the greatest contribution in refractive surgery was Dr. Randleman's paper published in January of 2008, when he kind of summarized the ectasia risk factors. And that was a great, in my opinion, that was a great job, because he could combine all the risk factors in a very nice way. And one of the things he showed there was that he was able to put that in a manner that each of the risk factors could contribute with points. The most important findings of that study, in my opinion, is the combination of the the risk factors. But more importantly, they highlighted, Dr. Random and the co-authors highlighted the importance of corneal topography and age as risk factors. But it's true, when we analyzed it 6 years later than that, we published the PTA in ectasia eyes, and when we compared those eyes, the difference between the PTA and the eyes that would have been considered at higher risk based on the ectasia risk score system, almost 80% of the eyes would have been considered okay to have refractive surgery. So why that happened? That's a very important question, since this is very important research, and having combined all these preoperative risk factors. So why this type of thing would happen? And the reason is because we had a clean data here with eyes with bilateral normal topography. So when we look back at the Dr. Randleman's data, and we saw the corneal thickness and myopia, and the spherical equivalent here, which is the representation of patients' myopia. When we look at those variables, we saw that those variables were very important in Dr. Randleman's risk score system. But when we look at the cutoff values he used, those cutoff values were very questionable. So when we look back to our data, the data that we had in eyes with, again, normal topography, and both the corneal thickness, actually, when you look at the odds ratio, not only it's very low, but the more important, it includes 1 in the confidence interval. Same thing happened with myopia. Look, it's very low odds ratio, and more importantly, it does include 1 in the confidence interval. So by definition, when we remove the corneal topography from the equation, we actually question those variables as isolated risk factors. Again, they are those are the same eyes. So see, they become more important as part of the equation from that PTA is derived as the ablation depth here in myopia, and as the denominator here in the corneal thickness, then just isolated variables. We can clearly see that here. And that happens because, as we saw, corneal topography was a very important variable in his paper. And most of those corneal thickness and those high myopic values were associated to an abnormal topography in that study. That's why those values were very important there. And when we removed the topography from the equation, they were not as important here anymore. And more importantly than that, more important as part of the equation that derived PTA than as isolated variables. Again, here's where myopia is as an ablation depth, and here's where corneal thickness is. Again, part of the equation that derives from where PTA is derived. So moving forward, we know, human beings, every time they have one thing that is considered a little bit new compared to what they have used in the past, like the residual stromal bed, we face the explore-exploit trade-off. It's how, when we are very young, we are in the explore phase of our life. We basically want to try everything new. As we get older, we are more to the exploit phase. We just want to use everything we had already in our mind, and we don't want anything new. But the research, in terms of human lives, are showing that the more you keep the explore phase of your life longer, the happier you are. So let's keep that in mind. So one of our new studies that will be published this year is when we compare the PTA using the central and the PTA using the thinnest point. So here's just an example of the equation. So here's the flap thickness, here the ablation depth, and here's the central corneal thickness. So if you have, let's say the PTA times 100, of course. So let's say if you have here 26.2% in this case, and then if you had a thinnest point that is different than the central point, the lower, of course, the corneal thickness, since it's denominator, the higher is the PTA. So if you have the average difference in normal eyes between the PTA considering the central corner and the PTA considering the thinnest point, the average difference would be 0.2 percentage points. This is not 0.2 percentage, it's 0.2 percentage points. So considering the example we gave here, it would go from 26.2 to 26.4%. The maximum difference we found in normal eyes was 1.2 percentage points. So again, considering our example here, it would go from 26.2 to 27.4%. And another very important finding from this study is that to reach 2 percentage points difference, we would go from 26.2 to 28.2. We would need at least 40 microns of difference from the central to the thinnest point. And that every time we found that, we recommend you to look back at the corneal topography because it may not be normal. Like this, it's a truncated bow tie that is one of the most overlooked patterns in corneal topography. So if the topography is abnormal, as our studies have shown, you should not consider PTA, because any tissue any tissue removal could be associated with the adverse event of ectasia. So now we have available a tool, and this is only in the Galilei device, that is called PTA Plus, that is basically considering also a machine learning and also a model with some constants here that kind of get together all the information related to PTA and the outcomes we have, so that we will change the value, considering all the data we have, and also considering some constants. This is proprietary, so there's an algorithm behind this one. But anyway, even if you use just the normal PTA calculation, you can calculate it with your hands. You don't even need any device. And I mean, we are showing why it's better than the residual stromal bed. This is the comparison we should make. So moving forward, regardless of having this display or not, you can calculate PTA with your hands. So again, one of the questions we get all the time is isn't it only the flap thickness the villain? So one of the studies that we did was we got eyes with thick flap thickness that did develop eyes with high PTA that did develop ectasia, and eyes with high PTA that did not develop ectasia, both with PTA higher than 40%. And the first finding of this study was that eyes both with high PTA that did and did not develop ectasia presented a thicker flap thickness. At the same time, we also investigate the eyes with thick flap thickness. We perfectly matched the eyes that with thick flap thickness that did and did not develop ectasia. And we saw that a thick flap was not enough to develop ectasia. The eyes would need a thick flap plus the ablation depth combining and both having high PTA for the ectasia to occur. So thick flaps were insufficient to cause unless they would accompanied by a higher ablation depth and the resultant high PTA. Also, another study that's going to be published very soon, it's already approved for publication, and is the study where we investigated the contribution of volume derived from modified flap diameters and thickness associated with different optical zones to PTA. Well, it's a long study to really explain here, but the most important thing is that we investigated two theoretical models, varying the optical zone and also varying the flap diameters. And the most important finding here is that 1% point variation of PTA enables to detect a change in volume as low as 0.3 millimeters cubed. And 1 millimeter variation of optical zone would mean a 0.5 millimeters cube decrease in volume and 2% variation of PTA. So finally, just to show you guys our most recent publication in ophthalmology, we showed here in a new validation data set that PTA again presented a high odds ratio, higher than 1, that further validated the high PTA value as a risk factor for ectasia. Again, here considering a totally new group in eyes with preoperative normal bilateral topography that did develop ectasia. We wanted to seek some external validation, and I'm going to show you two slides just to highlight this. First one is what literature says about ectasia eyes with normal topography. There are many great studies, and I always like to remember that those are not mutually exclusive. But it's very important to highlight this. Most of these studies, they have titles like this, why the residual stromal bed was not enough, to understand that patient is not a high-risk patient for ectasia. And again, they had normal topography, they respect the residual stromal bed limit. So what happened here? And again, despite all different explanations, and again, they are not mutually exclusive, they have one thing in common. All of these studies would present a high PTA, a PTA higher than 40%. Again, in medicine, any type of cutoff, is just a measure and an approximation of how closer we can get to a number to actually translate from science to the real world. We do that for hypertension, for glucose, for anything. Any type of cutoff could be discussed, and actually you can apply that. Sometimes you measure your blood sugar and you say, oh, it's higher than 110, but to me it's just fine. I mean, so we measure that all the time, and we use some cutoff values just to have a reference, or where you should go. In your practice, you can even use a higher PTA if you want to. That's okay. But anyway, anything that is higher than 40, you will just add to your risk factor. Another external validation from our study is a computational study conducted by Dr. BJ Dubs in his lab. And he showed that the PTA presented a higher correlation with the change, with the strain change after myopic ablation than the residual stromal bed. This is also a very important, in my opinion, very important corroboration of our findings. You can see here, it's a very good paper. Also, to finish here, lots of people ask me, so what if topography is normal and a high PTA is the only risk factor? We recently published a study just to show that you can easily change from PTA, from LASIK to PRK. So if you have a high PTA and a high PTA is the only risk factor you have, I'm not saying, well, you should not do refractive surgery. I'm just suggesting you to move from LASIK to PRK. And if you do that, we have shown that using mitomycin C, the results are very predictable, and you have another surgery that is extremely safe, and in my opinion, is the way to go if you have a high PTA. So again, this is what I'm trying to say here is that PTA is a risk factor, and a risk factor is what PTA is, and that's only what it is. Again, if you have a posterior capsular rupture, like you can see in this video, we don't want that, but I mean, that can happen. Endophthalmitis is a posterior rupture in the posterior capsule is a risk factor for endophthalmitis. I know many of us have seen that type of complication after cataract surgery, and not many of us have seen endophthalmitis. I mean, just because when this happens, that doesn't mean endophthalmitis will occur. It's just a risk factor. And I mean, we can have many examples of this and how this joint between perception and reality. And Dr. Daniel Kahneman, with the Nobel Prize, the economy Nobel Prize winner, in 2002, spent most of his life investigating this joint between perception and reality. And we are always trying to accommodate what is better for us. Again, you can go ahead and do surgery with a high PTA. I'm not saying for you not to do that. I'm saying it's a little bit better if you don't do that. And if you are not doing based on residual stromal bed, again, the residual stromal bed value was based on the assumption that it's just not true. Not to mention that cutoff is even weaker than any other cutoff you have been using in your life. So again, if you are talking about this myopia boom that everyone has heard, and we are very familiar with that, it's very important to understand what surgery you have available. In a very nice clinical survey that was done at the Oscars meeting in 2018 and published in the end of 2018, look how crazy are those numbers. most of people that were at the Oscars meeting are not doing any LASIK, PRK, or SMILE. 50% not performing any, and only 12% performing more than 250 eyes per year. So why this is happening? The answer from those people here is because they are afraid of ectasia. So again, if you are afraid of ectasia, I mean, maybe you should use those limits. I know sometimes we are considering everyone is an expert in analyzing imaging like we are, but it's not the reality. People are really afraid of ectasia. So, and this is a very scary clinical survey data that we have. I mean, people that were attending at the Oscars meeting, 50% not performing any LASIK, PRK, or SMILE because they are afraid of this complication. Again, this is part of investigation that we have done with help of lots of people that have helped me so much on this. Dr. Randman, Dr. Wilson, BJ Dupes, Glauco, David, Beatrice Kruger, and Natalia, Larissa, Carla Wallace. Lots of people that have helped me here throughout the years. I mean, more than 10 years now. So to me, it's a very important line of research. And again, I would like to thank you guys for the attention. And before I finish, I'd like to invite you all for the course that I coordinate in Rio. It's going to be, if the world comes back to normal, it's going to be between 17th and 21st of March of 2021. It's more than 60 hours of theoretical classes, more than 25 wet labs. We have everything is translated into English and Spanish. Last year, we had more than 600 people from. This is one of our round tables, and here we can see the attendance. So I already invited many of you guys to come. I hope you guys can come. Networking, different wet labs, like I said, all kinds of wet labs. So if you want to register here, just need to go there on cursorefrativario.com. Like I said, the whole course is translated into English and Spanish. Thank you very much for the attention. If you guys have any doubts, you can reach out to me at the Instagram. It's Marconi with Y, Santiago with TH. So I hope you guys, I have add my 2 cents of contribution here. Thank you very much for the attention.
Thank you, Professor Marconi, for this wonderful lecture. I think so lucky that we got to hear the complete PTA from you, and you've given the whole journey from the inception to what you're doing now. It's wonderful. I think we have a few more interesting talks, and we'll keep the questions till the end. We'll move on to the PRK section now. If Dr. Arthur is ready, you can talk. You can start your presentation.
Thank you, Rohit. I think what I'm going to do is I'm going to go through it more quickly because the questions are probably more interesting. Let's see if this is.
We can have it after Farad's talk, because his talk is also on an epithelium trans PRK for high myopia.
Excellent. So I think as far as trans epi goes, Shwint have been a long way ahead of what I'm going to speak about. So I'm going to reduce mine and just go through the basics maybe. So again, these are my financial considerations. So the epithelium covers the surface. It's normally between 40 and 60 microns thick. It's almost routinely 52, 53 microns thick if you're measuring. And it's normally very uniform and homogeneous. And it's nice to think about it the way you think about a contact lens. And this is a plano contact lens. It's got the same thickness everywhere, so no refractive power. But if you do find a lens like this that has thickening in the center and thinner towards the edge, it's going to have more power centrally, and it's going to correct hyperopia. So this, from those of you who are using epithelial mapping, this is following a ablation centrally. So I'm just going to share with you a case, and it'll make you think about how important epithelial mapping is. So this is a patient who had surgery 13 years ago for LASIK. She was -7, 54 years old now. She came back in a few years back with both eyes having regressed to around about -1.5. And we tried monovision for her with contact lenses. She really liked it, so we decided to treat just the left eye. This is what was at the stage where we had started we just started with epithelial mapping. So I was mapping everyone, but not really using the data to a large degree. This is a right eye, 67 microns, just showing you repeatability. This is the eye we treated, 63 microns and 64 microns. So again, showing really a high level of repeatability, even with an OCT. And so on the very first morning after doing a manual PRK, Vision's 2025, I'm thinking this looks on track. At week 1, it's 2030. Yeah, that's fine. We see many patients like that. But in a month, we get a nasty surprise. 6/30.2, really a +2 sphere equivalent, and a best corrected, it's pretty poor. And the epithelium now is 52 microns thick. So as we go over time, we see the vision getting very gradually better. Fortunately, the corrected vision getting better, and the refraction improving somewhat. So at 6 months, I said to the lady, I said, look, I don't really think we're going to see a change after 6 months. We haven't seen much in the last couple of months. And she said, well, I think it's getting better. Let's rather wait a bit longer. She was very understanding. And she improved one further line of best corrected. If you now look at what the epithelium did at the same time, in month 2, it was 51 microns. In month 3, it was 53 microns. Month 4, it was 54 microns. Month 6 was 60 microns. And month 8 was at 63 microns. Now, you may recall, we started with 63 microns. We're back at 63 microns. So you'd be thinking, well, hang on a second, we should now be back on target. But meantime, we're not. There's still this big difference. And here's why. This is what the epithelial map looked like prior to the enhancement, and this is what it looked like now. And you can see there's much more peripheral thickening and central thinning. So the epithelium is superbly important in refractive surgery, which is changing the shape of the cornea. And just as a reminder, if you're doing a transepithelial procedure, just ablating the epithelium is already a topography-guided procedure. So in this case, there's an elevation, which the epithelium to a large degree is masking. If we now just go and do a PTK, that's a block of tissue, a zero-powered contact lens, and we go down to the deepest epithelium, if you go and see what we did, and you're going to extract that, you'll now see that the treatment we did just by doing the PTK component is a topography-guided procedure. And so that's going to have an impact on your vision. It's going to improve the quality if you regularize the surface. So the smoothest surface on any cornea is the anterior surface of the epithelium. The stroma could be perfect below, and then you're going to have a very equally thick epithelium. But the stroma below could be quite irregular, like an old LASIK with a corrugated flap. And by doing this transepithelial, you're going to transfer the smooth surface deeper down. So how Streamline differs from what we did before. So for many, many, many years, probably 15 years, we're doing transepithelial PTK. But we would do a PTK in PTK mode that would tend to take away more tissue in the periphery, where with Streamline it doesn't. It's got a neutral PTK. So doing a regular PTK would make the eye 0.75 more myopic. We'd have to make that adjustment. With Streamlight or the new PRK mode, PRK mode on the wavelight, it's neutral. You could then follow with the regular procedure, you could follow with any profile. With the current Streamlight, you can only follow it with a wavefront optimized profile if you're going all the way through. The old system was a 2-step procedure. The new system's a 1-step procedure. And this is how we are doing it for now. We've been doing it for 2 years. We're staying with this protocol just to learn as much as we can. So we would first chill the corneal surface. Rohit, I loved your talk earlier. It was so good, the one on mindfulness. I really enjoyed it. And we have to be careful about how we spill and splash and do all these kinds of things. But anyway, we would do the PTK, take it to the thickest point of the epithelium. Then we would take a 10-second pause just to let any heat dissipate, and then do the refractive component. And then again, add ice or chilled water. So you heard Streamlight is mostly it's designed for a wavefront optimized profile, but you can in fact combine it with other profiles. You can enter the refraction that you want to treat. That then designs the PTK component. You do the PTK, stop before you do the PRK, and then load the new profile. So it can be done that way. And I think that's about as far as I want to go. The results have been very, very good. I'm delighted with the way they look. They're actually slightly better than the results we're seeing with manual PRK. We've been following them now for 2 years. But I think the discussions have been so good, we'll have more discussion about the process rather than just my results.
So what we'll do is we will take up Dr. Farad's question, Farad's topic. Then maybe if you have time, Sharon can just run quickly into what really makes the haze other than just the laser beams. And then we'll have question and answers. Is that okay with you? Professor Farad, are you ready?
Yes, thank you very much. Do you see my screen?
It's a great honor again to introduce a good friend. And I learned cross-linking 2007. You both were very young then. I think you were with Professor Theos. And I did visit you then, and I've been coming to your meeting for the last 12 or 13 years now. I thank both of you, Dr. Nikki and Farad, for being here. And I think I'll have now on, we start with your sections, this one, cross-linking and the future. And like I told, for all the attending people, all your questions have been taken care of. Like I said in the beginning, this we try not to keep too tight on the time, and so that that we have a lot of discussions. I'm thankful for all my panel to be here and be part of this. Professor Farad, please.
Well, Professor Rohit, thank you very much for your kind words. And we all know that you are not only attending the CXL Experts meeting, you are an integral part of it. So, but this talk today is not about cross-linking, it's about transepithelial PRK. Let me show you what this is specifically about. First of all, this is a directed research project that we have been doing between the University of Zurich and Schwind iTech Solutions in the past 6 years. Now, what interests me as a refractive laser surgeon is, on one hand, sometimes I am facing therapeutic challenges that I would like to correct with a therapeutic refractive laser approach. Let's take this scar that is at a certain depth. And this depth is normally too deep. This goes to almost 200 microns to be assessed by, let's say, a PTK. And so I have to enter into anterior lamellar surgery. The question would be, if biomechanical stiffness would allow for it, why can't I remove this with a laser? Another example would be, again, as a refractive laser surgeon, what's happening now? Let me see, here is the one, sorry. As a refractive laser surgeon, I would love to be able to do such a refraction in a surface ablation mode to maintain biomechanics. Now, if we look at the numbers below, minus 12.5 diopters, we are not doing this today, but we have been doing this some 20 or more years ago. And you might all remember these old studies that were doing PRK for minus 20, 22, even minus 24. There is a good reason why these studies have been abandoned in the meantime. And the reason is an event that happens in the cornea that is almost impossible to control. We know that the amount of phase is also proportional to the depth of stromal ablation. So at a given point, you get into more and more trouble if you remove too much tissue in a surface ablation. So you get into excessive haze. Here are just some other clinical pictures we are all very, very familiar with. Now, what do we do when we try to avoid haze? Well, there is not a lot to do except putting a very toxic substance onto your cornea, interfering with the wound healing process. And any of us who use mitomycin C routinely have had a learning history with it, and we have a lot of respect using this substance. So this is the reason why we started looking into why can't we do a PRK, a trans-PRK, without using mitomycin and still going very deep. Now we had to go back to the very basics. Let's just lean back for a second and think about, how did this whole business start? More than 30 years ago, surgeons told technicians and physicists, we would like to reshape the front surface of the eye so that the focal point gets into shape. And then it was up to the physicists and technicians, engineers, to find solutions. And all these solutions, if we look at everything that has been developed so far, it is mainly mathematical and physical. You need certain formulas to describe how to ablate. You need to pay respect to the laser beam to get more and more precision. You have to look into the profile of the individual laser beam. The only thing we have told the engineers is, please do not make our tissue too hot. If you heat the cornea up over 42 degrees Celsius, we run into trouble because of denaturation. Yeah, this is the only thing, and this is why we have flying spot lasers. But everything else was determined by non-surgeons. Well, of course, the end result then is exactly where we want it to be. But just think about it. The way the approach is distributed has not been determined by us, the surgeons. But then again, in the end, we are responsible for our patients. And if you plot a refractive laser surgery over time, then let's say you do a PRK, a trans-PRK. Now, on the left side of PRK is before surgery, on the right side is after. Everything you do before PRK is a lot of mathematics and physics. Of course, you check the cornea at the slit lamp and everything is fine, the retina is fine, but then you dive into refraction, into wavefront errors, into Zernike coefficients, and so on. Then you perform the PRK. 4 weeks later, the patient comes back with excessive haze. What do? All of a sudden, you're not a physicist anymore. You're an MD. You think in biological terms. Oh, I need to use steroids to suppress the immune response. How can I get my hand on the biology of this tissue? Now, our approach was, why do we think physical before, biological after? Why don't we think biological before we even touch the patient's eye? Which means, can we optimize ablation profiles using biological parameters? In other words, you see how the sculptor hits the stone, and every hit means a certain fluence, a certain depth of penetration. Maybe there are ways to use the fluence and the distribution of spots and the consistency of the stromal wound bed that get you to the same final result, but with less expression of inflammatory markers. And this is what we've been doing. So the first step was an animal-based lab study. We performed deep trans-PRK in rabbit eyes. And we talked to the engineers of Schwind and said, we would like to have a special firmware. This was the only time back in 2013 where my experimental laser was a 1050 and my clinical laser was a 750. So the rabbits had a really, really special treatment. We performed standard fluence treatments as a control and then low fluence treatments that had a different fluence distribution of their shots. The final result was the same, and the time lost per diopter was less than a second per diopter, so quite similar clinically. And then finally also we took into consideration the smoothness of the stromal wound bed, which is called Smart Surf by Schwind. Please note, I am not a paid consultant of Schwind. This was a directed research project. So Smart Surf means was introduced in 2015 and creates a very smooth surface at the end of the ablation, roughly 40% smoother than in previous generations. Now, we looked at the corneas, homogenized them, extracted the RNA, and ran differential displays to understand what happens to differentially expressed inflammatory genes. Now, the study ran over 6 years because we had to do several phases, phase 1, phase 2, and phase 3. And at the very end, I will just summarize very briefly, we found distinct differences between these different ablation algorithms. And to our greatest surprise, we found a reduction of more than 60% of post-inflammatory expression levels of markers, but not in low fluence mode. It was the smoothness of the bed that was key. In other words, this Smart Surf module should allow for deep ablations clinically. And the future could be go really deep, rival anterior lamellar keratoplasty. So next step, we went from animals to the human study and looked into this. The Smart Surf module is already installed in the Schwinn software. And so we looked at the post-op haze after trans-PRK in very high myopia without using mitomycin. And the study now I think is at 27 eyes with more than 6 months follow-up, but this is what has been now prepared for this talk. And as you can see, the stromal ablation went from 80 to 140 microns, and that would be 10 diopters of myopic correction in the 6.5 millimeter zone. No mitomycin, see? And what was most interesting to us, the amount of haze we assessed, and we assessed it both conventionally at the slit lamp in the clinical grading from 0 to 3, and also by means of Scheimpflug imaging and densitometry analysis. The haze was always controllable clinically and never became a major issue. And the mean stromal ablation was 106 micron. Just for comparison, before we started using trans-PRK in this mode, I started using mitomycin C roughly at 40 to 50 microns of stromal ablation, even in a Central European setting. And again, clinically, the haze was totally controllable. So in conclusion, a trans-PRK of more than 100 micron with mitomycin C is possible without clinically relevant haze. I'm currently at 12 diopters already, and I still don't see haze that is bothering me clinically. Again, this is a Central European setting, and I'm very well aware that in other parts of the world, different conditions, different sunlight exposures must be taken into consideration. But again, we did not start from 0 to 100 in a day. We just went up very slowly each time to see where the individual limit is. So when I talk to friends from Oman who start using mitomycin C at 1 diopter of myopic refraction, I told them, please just start very low without the use of mitomycin, and then just go up very gently to do this in a responsive, in a responsible manner. This work has been presented at last year's main ESCRS and another part of it at the winter ESCRS. And we were very happy to see that at both meetings, we won the Refractive for the poster prize for it. And of course, this is a teamwork. This is not a single player's work. And this is our team at the University of Zurich and the ELSA Institute. Thank you.
Fantastic. I think fantastic talk, both of you, as usual. Can we have the panel to start some questions and some discussion, because this is PRK is such a hot topic always. Dr. Rajesh, would you like to pick on something?
I think the most important point, what I liked was that he clearly specified that the population that he was treating with his protocol, and if you are in the equatorial zone with increased UV exposure, we know that increased UV exposure is a risk factor for development of haze. So it seems prudent to start with lower degrees of myopia and then gradually take it to a higher level and see what the outcome is. Just the other thing that I wanted to find out, Dr. Farad, is what was the duration of use of topical steroids in your patients that you treated with high myopia? You did the surface ablation. What duration did you use the topical steroids for?
I used the same clinical regimen I use in all my low myopia cases. So as soon as the epithelium is, now we already start immediately with non-steroidals and steroids, but once the epithelium is closed, I go to fluorometholone and assess the haze after 2 and 4 weeks. And if necessary, I switch to dexamethasone preservative-free and dependent on the haze. And I usually give steroids over a course of 3 months.
Any other questions?
Yes, Rohit,
Yes.
Dr. Hafezi, what's the deepest ablations that you do now? Like you said, -12, and I mean, going beyond 100 is good, but that would be like 130 or 140 microns. So what's the deepest you're going, and then what's, if you do use mitomycin at some point, then what's the concentration and duration?
The deepest I've went so far was 140 microns. So effectively 10 diopters at a 6.5 millimeter zone without the use of any mitomycin. For now, I'm not using mitomycin in myopic corrections anymore. But again, before in our Central European setting, I started using 0.02% for 30 seconds. No, for 20 seconds only at 40 to 50 microns, and I went to 30 and 40 seconds for minus 6, 7. But ever since, we've completely stopped using it.
I would like to tell something about this in an Indian scenario. You know, India is a country which has mountains. It has a huge coastal region which is closer to the sea. And I come from Bangalore, which is away. It's on a higher sea level. When I operate patients who are totally closer to the sea, I tend to always get haze whether I use mitomycin or not. And the place where I stay in Bangalore, I've had cases where people have no haze after 1 month, 2 months. They relocate to a place which is coastal and they have suddenly developed haze. So one of the things which I make sure I write in my file, and I change my routine if the patient is going back to a place which has more UV light. And my regimen is completely different if you're staying in Bangalore or if you're going back to Mumbai or Goa or one of these places which is a sunshine place. So I feel, as Dr. Fogla said, it's very important where the patient is from. And the same thing cannot be applied. Even in a country like us, it's even with the same genetic level of, which genetic which can predispose to haze. So Pooja, what questions do we have for both? I have one question to Dr. Arthur. When you do a transepithelial, you showed a picture where the superior was 60 microns, the center was 45 microns. What would you do in them? Do you do a manual epithelial removal or you do a PTK, PRK on them?
It's a great question. So we have a chat with the patient and see what they're looking for. And if the patient is saying, I just want the vision corrected and I don't have complaints of glare or halos, we just do it manually. But if a person says, no, I would like to improve the quality, what we'd say to them is, well, we're going to do a transepithelial. That's going to improve the quality because it's topography guided, as I explained, but it might make our predictability slightly less good. So it means you might need another adjustment. So based on that, I'd like to add something. I really enjoyed Ferry's paper. It's excellent. Very, very good. As far back as 2010, I did a paper at the AAO comparing LASIK between -8 and -12 to PRK between -8 and -12. And we've always used mitomycin, even though we live in Ireland where there's not a huge amount of sun. But we used to use mitomycin only above an ablation of 50 microns. And we started seeing our -5 patients look better post-op than our -2s. And so because we've seen no complications with mitomycin used for PRK, we decided to use it as a routine. And the fascinating thing about this paper, it won a prize over there at the AAO, was that there wasn't a big difference in the refractive outcomes between LASIK and PRK, between -8 and -12. So it's a really viable procedure. I love this idea of the smart surface reducing the amount of haze.
You raise a very important point, Arthur. And I think this is highly interesting. And what I suggest is not to omit mitomycin C in the beginning. And just as Professor Rohit has said, when you start something new, you have to define very clear rules. Just imagine cross-linking 15 years ago. There was only one rule. And today, we do it very differently because we look at a map and no, I want to induce flattening. I do not want to induce flattening. This is central peripheral. Same thing in refractive. So the way we could use the data our group has generated now, it might help us going higher than we went before. So if your upper limit was -12 using mitomycin, then maybe in combination of mitomycin and a smoother bed, you might be able to go up to -15. And this, I think, becomes very interesting in the therapeutic approaches. If you are facing irregular astigmatism in a non-keratoconic eye, let's say an old scar, in a really good thickness.
How will it be different? And if you can tell them about the same? And there have been 2-3 questions on the same.
So ideally, what will happen over time, we heard Damon's fantastic talk on AI, and I think what's going to happen over time is we're going to be using AI more for RL power calculations. Already we use the Hill RBF and some other formulas like that. But I think just generically doing an innovised case versus a regular procedure, I'm guessing. I don't have any data, but I would imagine if I look at the corneas that we achieved with ray tracing LASIK, that we're probably going to have less surprises because the cornea is more physiological, and the way the ablation zone blends into the untreated part is just more physiological. But I don't have a complete answer.
So we've been discussing about mitomycin. I've just asked Sharon to share one slide, which I would like Professor Farhad also to have a look at it. The reason is he spoke about genetics of haze, because now we have realized that all haze is related not to the laser. Laser is probably a small culprit. It's all about how your genes are. So we've been working on it. We've been presenting it in various platforms about an epigenetic modulator. It's like, how do you modulate the genes which cause haze as a drop format? I don't call it the real gene therapy of haze, but it's actually something which not creates, which works at exactly the genes you have mentioned in your paper. It's just a one slide presentation. If Sharon is ready, she can just put that slide. And I would like Arka to comment on this also.
Yeah. For some reason, my screen share is disabled. Mr. Ashok, can you check that? Otherwise, we can.
Okay, we can move on to the questions. When you're ready, we can.
I'm sorry, it says disabled.
So Arka, can you just talk about it?
Yeah.
Yeah, right. So one of the reasons people have been looking at alternatives to mitomycin C usage is that it does kill the keratinocytes. I mean, that's the mode of function, that the myofibroblasts that form when you have an injury, which are sort of the runoff that causes haze to begin with, can you kill them off? So that's what mitomycin C does. But there's a safer way, which is to use these histone deacetylase inhibitors that regulate the profibrotic pathway to begin with. So you can sort of reprogram these myofibroblasts to not become, to not persist anymore in a myofibroblastic stage. And so you block off the TGF-beta pathway and regulate haze formation. So that's the idea behind using an HDAC inhibitor like SAHA, which is Vorinostat. I mean, it's already used in cancers and all. So as a topical eye drop. One of the things that I would like to ask Farhad also is that you've done these experiments in animals, but one of the things that we observe in animals is that the recovery in the animals from these surgeries is pretty good on their own, which is slightly different from how the human eye responds to these. So when you are doing these surgeries with mitomycin C, do you think the same kind of dosage is going to be helpful in the human eye?
Well, it's a very good question. Luckily, we already have the answer, because when we had to switch from the animal studies into the human condition, because we identified corneal smoothness as the factor, we were confronted with SmartSurf that already had a CE mark and was implemented in all these lasers. So what we did, we simply prospectively collected our data and went beyond the normal indication in terms of diopters. This made it easy, and luckily the human condition reflected what we have found in rabbits, which we all know is not always the case. A few years ago, when I was still at IROC, I used TGF-beta on mouse eyes after refractive laser surgery, after deep PTK, and we had massive reactions. So we were not able to use TGF-beta knockouts because we didn't have tissue-specific ones, and the normal knockouts, they are not viable. So I'm very happy to hear that you think about interfering with the TGF-beta pathway.
I think we have this slide, which is very important, exactly something similar to what you said. What Sharon has shown is that this is work from Rajiv Mohan's lab, where ARCA was working. They looked at a -9 diopters. Sharon can explain this better because the slide control is with you.
Okay. Basically, very quickly, this is what we know to be the mechanism of formation of scar. Okay, and as the healing goes, this is the timeline of days, and we know that there's a lot of inflammatory markers which play a role, which have both pro-inflammatory and pro-fibrotic, effects. So as was discussed previously, if we use mitomycin C, it does stop this, but it also has a lot of toxic effects on the tissues around, especially the keratinocytes, the fibroblasts there. So the idea was to try and find something which will have a role and reduce the fibrotic components, and that is what SAHA drops does. It reduces the pro-fibrotic effect there by inhibiting histone deacetylase. So that is what is seen there.
So ARCA, if I'm right, it's an epigenetic modulator because it works on the genes of TGF-beta.
Right. It works on groups of genes. One of the primary gene groups are the pro-fibrotic genes, including all the SMAD pathways that regulate the TGF-beta response. So in this slide, what you can see is the green in the cornea section that you see. Those are myofibroblasts stained for alpha SMA, if I'm not wrong, and that is reduced when you follow up your surgery with SAHA drops. So,
and again, being optimistic here, this can also be used in future if you're not used anything on the patient during the surgery. If the patient gets scarring, this can be used later also, right? Without any collateral damage. I'm just speaking optimistically.
After scarring has set in, not so sure about that, but it will definitely be beneficial. But I'm not sure that it has the power to reverse it completely. So that is because once the scar collagen has formed, is the problem of removing the collagen rather than stopping the profibrotic process.
Like I said, the best thing the COVID taught us is to be optimistic of everything in life.
Yeah.
That's very interesting. Congrats. That's really nice.
So can we move on to the next case by Ritika? And Ritika, thank you, Sharon. And we'll keep the questions coming as we get, and panelists also can share. So Ritika is a good friend, a leading eye chain hospital, one of the biggest in the country now, called Center of Sight. She runs the hospital and also very prolific cataract refractive cornea surgeon. Dr. Ritika?
A very good evening, and thank you, Dr. Rohit, for the opportunity to be part of such an interesting webinar. I think by far, the most interesting few hours I spent in the lockdown. So I'll just be talking about our approach to handling regression, and a lot of this has already been covered in terms of the focus on the epithelium and the inflammation. So as refractive surgeons, we are looking at a perfect target, and with the new technology that we have with better delivery of lasers, we are more likely to reach that target. So the rate of which we see patients who regress or drift from the ideal postoperative refraction is going down. From rates as high as 28%, we are now down to less than 5%. Regression or deviation from the ideal postoperative refraction and drifting towards the preoperative refraction is multifactorial, and some of those factors have already been discussed beautifully. The role of the epithelium, as Dr. Arthur pointed out, is really very important. The epithelium tends to smoothen out any irregularity. So when you flattened the cornea for a myopic correction, you will have more hyperplasia of the epithelium trying to undo the change in contour. And this hyperplasia will manifest as a regression. What is most important to note is that this regression is normally mostly seen in the first few months, and fortunately in LASIK stabilizes by 3 to 6 months, but the epithelium changes in PRK literature are noted as far long as 3 years. So that is what Dr. Arthur was also illustrating, that you may need to wait many, many months to get these epithelial changes to stabilize. Another important point to note about epithelial changes is that whenever you've had more trauma, you've breached the epithelial barrier or the Bowman's membrane, you will have an upregulation of cytokines, and this will upregulate the limbal stem cells and enhance the possibility of the optical regression due to epithelial hyperplasia. So as LASIK surgeons, we have to be gentle on the epithelium, and the epithelium is the new focus area for all refractive surgeons. Of course, it's not only the epithelium, but also the stroma that we have to take into account. Stroma is 90% of the cornea, and but however, less of it is cellular. You are subtracting collagen from the stroma. This is a sudden instant subtraction, and therefore there will be biomechanical changes in the stroma. This will manifest as a weakening. Some studies have shown that the posterior curvature actually changes and it bows forward, and this may also contribute to regression. There are a lot of inflammatory mediators which have been spoken about, and these also contribute to laying down extracellular matrix and fibrin and gags, and this contributes to a stromal thickening that can come in and contributes to regression. We must never forget the lens when we're looking at regression. We had a patient, and this has been reported by Dr. Rohit Shetty's team also a few years ago, that came in with at the age of 50 with myopia. The topography scans, the epithelial scans were all normal. The myopia was actually due to lenticular nuclear sclerosis causing index myopia. So don't forget the lens, always look out for the lens. I'll just be now moving on to certain cases. Now, what do we do when we are faced with a regression? We must do the refraction. 3 months for low myopia with stable refractions, and we normally would like to wait for 6 months for high myopia and hyperopes. Of course, the tomography and the epithelial mapping has to stabilize. Rule out lenticular myopia, treat the ocular surface so that your refraction is accurate, and always do an anterior segment OCT. This is the, you have to know the flap thickness, the epithelium thickness, and rule out any flap complications, especially if the patient has been operated outside and you have less data. Flap relift is what we do for a lot of our patients who come in early, and we have operated them and we are sure we are dealing with a healthy, meaty flap. This has to be done carefully. Let me just show you a video. So this is a patient of ours. We are taking this patient up, everything is stable, and this is at 1 year. So whenever you're doing a flap relift, this is a technique that I love to follow. Just dry the cornea and press gently. Here it is a relatively recent, it's less than a year. So we are able to lift quite easily. Microkeratome flaps lift easier than femtoflaps, but femtoflaps also lift quite easily. We have to be careful to not injure the epithelium, because then we are going to get much higher risk of epithelial ingrowth, and that's what we want to avoid. So as you can see, these flaps lift up well, and you have to just retreat and reposit this flap back on. Post-operatively, the epithelial injury you need to monitor specifically for epithelial ingrowth. Some people like to place a bandage contact lens on. There are people who have lifted flaps up to 12 to 15 years, but normally after 3 years, the risk is significantly higher of epithelial ingrowth. Now, this is a patient who came to us, was operated elsewhere. The only history that the surgeon gave was that the patient suddenly got off the bed. This patient is actually an MBBS student, and the surgeon did not even know how the microkeratome pass was. He managed to lift whatever flap he could and lasered the patient. So the patient was very unhappy. We were getting a consistent refraction, but the patient was not improving very well with refraction also. So we decided this is a many years earlier case. This is a microkeratome. So we decided to recut. When you recut, you obviously try and go deeper than the original flap. And we had done an OCT, and now we are going deeper than the original flap. Now, as we lift the flap here, you see what has happened. There is actually a sliver. It's almost like dealing, you feel like you can have retained lenticules in SMILE, but this is what had happened. There was a sliver of the previous flap. There were possibly a jerky pass and a partial cut in the flap, which fortunately for us just unveiled itself once we were doing a recut. So this had folded on itself and had actually caused the central island of steepening. This was not visible at all on the OCT. This is, of course, many years earlier, and the OCTs now are better. But we simply reposited this back and then wanted to see how the topography regularizes, and the topography did. So there are sometimes surprises that throw up even in recuts. This, of course, was a pleasant surprise because it allowed us to really get to the bottom of the cause of the really aberrated topography. Surface ablation is something that must be done when you're not sure of the flap, or there are flap wrinkles, there's a decentered flap or a very thin flap. And we were doing a lot of surface ablation when we did not have the circle scan for SMILE. We used mitomycin C in all cases for surface ablation because studies have shown, and we have seen, that the inflammation is much higher when you're retreating. Fortunately, there is no linear correlation between regression that has happened once and regression that will happen after retreatment. So just because these patients have deviated once doesn't mean they will deviate again. This is something that I personally haven't done much of because we now move more to SMILE. But femto laser side cut, particularly if you've had a microkeratome flap, you don't want to relift the same flap and risk epithelial ingrowth. You can use the side cut only method to create a fresh cut, which should ideally be inside the original flap. You keep this cut about 20 microns deeper to compensate for the change in flap thickness that may have happened due to changes such as epithelial remodeling. And you can then create a new cut and lift it up. But do remember, another side cut is a significant biomechanical weakening force. So you have to have a good residual stromal bed to perform the correction. As SMILE surgeons, earlier we were faced with problems of enhancement, but in our hands, the enhancement post-SMILE is definitely lesser than after LASIK, and the rate remains less than 2%. There are surgeons like Dr. Dan Reinstein who perform a very thick cap SMILE and therefore can do a flap over that cap. We do not do a very deep level of dissection in SMILE, and therefore we use the circle scan to really enhance the patients who've undergone SMILE. And it has worked very well in our practice. I think Sheetal has already shown the circle scan. So this is the circle scan wherein you've had the lamellar ring cut to just extend the flap beyond so that it gives you good space to carry out the correction and therefore treat the regression that has happened. So I think as refractive surgeons, we are seeing newer ways to understand regression, particularly epithelial modeling. And as refractive surgeons and in life, we should always keep calm and we can always get things back on track. Thank you.
Thank you, Ritika. Wonderful presentation on regression. We went from a simple regression from an epithelial remodeling to finally ends up with, in the SMILE, the whole algorithm you have written. From the panel, anybody has anything to add on this?
I have a small point about the side cut only. It's a little challenging sometimes because you have to ensure that your cut is well centered.
Yeah.
And if you are even a little bit decentered and your edge crosses over on the other side, then you'll have a problem.
I'm personally not using much of side cut only, given the fact that we SMILE. Yeah, but
Dr. Ritika, based on your experiences, do you have nomograms for PRK, LASIK, and SMILE, or you don't use any nomogram?
So we do use nomograms. One important factor is when you have regression, you have to go back and analyze. And we have started overcorrecting In fact, we have different nomograms. We have surgeons who have different nomograms. I prefer to overcorrect in my smile patients. You actually need to tell them that they may not be having the instant wow, because there is some regression that comes in, particularly in higher myopes and in astigmats. So I do prefer overcorrecting. The patient will develop a rapport with you and will be able to wait out a few weeks to get the good vision. However, I have surgeons in the same institute who don't overcorrect. So we've developed nomograms which are not only institute specific, but surgeon specific. And I feel the endpoint should be a month, and sometimes the wow at 1 day is overrated.
I think we'll move on to the next session. I think this is one of the most awaited session of keratoconus and cross-linking. We have 2 talks by Farhad and some small talks by our team. We'll start with Dr. Farhad, very favorite topic from him on treating thinner corneas. And there are very many methods of treating thinner corneas. His is based purely on a mathematical model of using the fluence for treating very thin corneas. I think it's one of my favorites. So I think all of us are waiting to hear this. Professor Farhad.
Thank you very much, Professor Wahid. Do you see my title?
Absolutely clear.
Fantastic. So this is a talk about cross-linking in ultra-thin corneas, what we call the sub-400 protocol. These are my financial interests pertinent to this presentation. Now, we all know that the 400 micron stroma limit that has been imposed by the original Dresden protocol is something that had been developed almost 20 years ago. And it is also a clinical reality that many of the patients that need us most have a cornea that is thinner than 400. So from the very beginning of clinical cross-linking, we were facing the challenge, what do we do with the thinner corneas if they have a progression, and if we can stabilize them while they still have a useful vision. And nowadays with scleral lenses, many patients with far advanced cones still have a surprisingly good vision if we were able to stop them. Now, this is a typical case of a cornea that would need, with progressive keratoconus, that is normally beyond the reach. Now, as you can see here, this is a 220 micron stroma cornea that we have cross-linked. And as you can see, there is a demarcation line that is nicely 60 to 70 microns just before the endothelium. How did we do this? Let me show you how. In the very beginning, there were other protocols that have been used over years for thin corneas. These are the most popular ones. We started in Zurich in 2009 developing hyperosmolaric solutions. This is the original swelling of the cornea approach. Then a few years later, Susan Jacobs had a very nice idea of putting a contact lens onto the cornea. And finally, also a few years ago already, Cosimo Marzotto proposed, well, if the cornea is too thin, let's just leave the epithelium over the thinnest areas. Now, I'm not using any of these methods anymore because in my eyes, every single one has major disadvantages. Let's look at the disadvantages. The swelling method that we have established works on the fact that osmotic pressure can swell the cornea, increase thickness. Now, interestingly, the biomechanics of a swollen cornea after cross-linking seem to be quite good. Wollensack has yet published another paper last year. So if you swell the cornea, you shouldn't be worried too much about the biomechanical effect. What bothers me as a surgeon is that I never know which cornea will swell and which doesn't. Already in our original papers, we had corneas that swelled 30 microns, other would swell more than 100. So you are always facing a certain degree of uncertainty once you start the procedure. Will my cornea swell enough, yes or no? Susan Jacobs' approach places a contact lens on top of the cornea. This has a major disadvantage also because you will find 2 papers that came to the exact same conclusion. We published a JRS paper in 2015 looking at contact lens assisted cross-linking, and we had a 30% reduction of efficacy. Wollensack published a paper last year, 30% reduction of efficacy in contact lens assisted cross-linking. Why? Because you interfere with oxygen diffusion. And so there's not enough oxygen for the reaction to be effective. Now, if you look at Cosimo Mazzotta's epithelium island approach, we tried it for some time, but this also gives you a very strange pattern of on and off haze with all its related consequences. So I do not think that this is a really good approach either. So none of the approaches was satisfactory in my eyes. So we went back to basics and looked at corneas without the epithelium. On the left side, a 400 micron cornea. So we would treat it with a safety margin to the endothelium. And if the cornea was way thinner, we would potentially harm the endothelium. So all the techniques that I've described to you right before, they aim at increasing thickness, swelling the cornea, putting a contact lens on it, leaving epithelium. It always plays with the thickness of the cornea. If you think about what factors we can influence in a cross-linking reaction, then thickness is only one of them. You could theoretically also modify riboflavin concentration, right? If you go from 0.1% to 0.4% riboflavin, then you would have more molecules in the superior cornea, more absorption of light, a more shallow reaction. Clinically, this is absolutely not feasible. Just imagine having 25 different solutions of riboflavin in your arsenal, just like a stock of IOLs, and you have to pick the right concentration for the right patient. That's clinically simply not a very practical approach. The best approach would be to adapt the fluence of the entire reaction to the individual patient. And this is what we call keep it simple. In other words, if you're facing a 400 micron cornea, you should have enough fluence to go down to 330, 70 microns before the endothelium. And you should be able to adapt your fluence if the cornea gets thinner and thinner, which means this would not be 3 milliwatts for 30 minutes, but 3 milliwatts for another term, or 9 milliwatts for another term. We know enough about riboflavin diffusion and oxygen diffusion to we were able to create an algorithm that was published 3 years ago. So instead of keeping this just for us, we decided to make this public knowledge. Based on these formulas, a nomogram can be derived, and we have transferred this nomogram into a prospective clinical study. We now have 47 eyes with a 1-year follow-up. The work has just been finally submitted. We waited for all 1-year data. And the thinnest we have treated so far was 214 microns of stroma. Outside the study, we even have treated a 210 micron keratoglobus case and 2 eyes, and this worked fine as well. But within the study, it was 214. What we did is remove the epithelium, measure your thickness after removal, which means by means of ultrasound, then apply your riboflavin, and right before you shine the light on the eye, measure with ultrasound again. With a little bit of exercise, you will find the thinnest point quite well, and then you transfer this amount, let's say 290 microns, into your nomogram, which basically is a table that gives you the amount of energy, intensity and minutes that you should apply to go deep enough but not too deep into your stroma to see a demarcation line. Now, when looking at the results, the reduction in Kmax readings was not too much of a surprise. What surprised me a lot was the success rate. I did not expect 89%. I would have been happy with 65 or 70% because these were ultra-thin corneas. Now, as soon as the results are published, this is in the public domain, anybody can use it, but the CI device of Imagine will have the entire nomogram integrated into the machine, which makes it a little easier. All you need to do is put in the thickness of your cornea, and the machine will calculate the total fluence. One last thing, my friend Cosimo Mazzotta has developed another protocol for thin corneas he called the M protocol. Now, what is the difference between our sub 400 and the M protocol? It is what Professor Sherry has mentioned in the very beginning. We have developed a protocol from the scratch. We have created a sub 400 that has an algorithm and calculates the fluence. Now, Cosimo Mazzotta has taken a different approach. His M protocol is a compilation of all the solid studies that have been published in the last 20 years. So he knows that taking, let's say here, a 15 milliwatt pulsed approach, iontophoresis based, would bring the demarcation line to 280. But if you want to have a more shallow demarcation line, you might want to use 30 milliwatts of continuous light, which is at 200. So basically, it's an accumulation of published knowledge, and our protocol is a newly developed algorithm. I think there are many ways to roam. The main difference I see is easiness. I think individualized cross-linking is the future. You can do very thin corneas, but our approach can be done with the oldest machine on this planet. If you have a 3 milliwatt machine, then you can use the protocol. Whereas in the M protocol, you need more sophisticated technologies that give you continuous light, pulse light, and different intensities. Thank you very much for your attention.
Thank you, Professor Farhad, for a great talk. What we have done is we have taken from your paper, we have made this algorithm as small on an app. So if they don't have to, they can just enter it. It's freely available. If somebody has not got it,
nice.
So it just tells you exactly, if you just feed in, it will tell you which machine are you using. You're using the older, younger machine, and it just tells you. So we just made it a little easier for our users. I think
that's great.
Thank you. We are close to 70 or 80 eyes now. We are close to 6 months follow-ups. It really works well. You don't need to work on anything. You don't need to worry about swelling it up. It's
great. Yeah, fantastic. Great to hear. Please send me the link to the app if you can share it.
I will do it. I'll do it today only. Any questions for Farhad?
Yeah, so I was wondering, Rohit, that do you now swell at all? I mean, I understood that you can go to thin corneas, but do you make any effort to swell at all, or you just don't make any effort to swell the cornea at all for very thin corneas?
He had, I think Farhad has spoken about this 2 years back, and we've been doing it with that. That time the paper was not published. Now it's published, and we've not gone so low as 200. And most of our corneas have scars when they go very low, but at least the thinnest I've gone is 310 because it's a clear cornea. There was no signs of any scarring, and it didn't really need. And the patient is now close to 8 months, good demarcation line. Everything what you see in the normal cross-linking. And we do an endothelial count for all the patients. We've been doing confocal microscopy, and it's just holding on well.
Yeah, we've also used it for about 4 or 5 patients, and we've got very good results.
Hi, Rohit and Hafezi. Can I ask a question real quick?
Please.
What for both of you guys, what kind of riboflavin are you guys using? With which vehicle? With HPMC or dextran?
On our end, we have developed a hyperosmolaric riboflavin that does not carry either HPMC or dextran, similar to the iontophoresis approach that Soft Italia has with the Ricrolin Plus, because you don't necessarily need the HPMC in this manner. Once you have a standardized approach, whether it swells the cornea a little bit or not, and this nomogram, you do not have to worry too much about variations. You simply take the final value and implement it. So on our end, we didn't have either HPMC nor dextran in our solution.
I've used HPMC, not dextran, because dextran again dehydrates the cornea.
Yes. Yeah, but that's a very important difference between both of you. I mean, I think this is very important to be highlighted, because the vehicle could change the interaction, and more important, could I mean, just going back to basic science, that could create a little bit deeper cell death. And maybe that should be taken into account. I mean, I was going to get into the whole haze conversation. I just didn't want to make it too long. But I mean, this is another important area of research. So I think it's very, very nice to maybe go deep on that discussion, you know.
We did, basically what we did was we did a confocal microscopy of all these patients. We measured the whole structure from epithelium to the endothelium. And interestingly, the cell death and what we see normally with cross-linking, with the thicker cornea cross-linking, we did not see anything extremely different when we were doing on a thinner cornea cross-linking with this new fluence. We did not see more cell deaths. We did not see anything which is more collaterally damaging, as you know, posterior cornea was not. Posterior keratocytes were not really damaged, and posterior keratocytes are necessary because they are the ones, when there's a damage on the anterior keratocyte, they are the ones which keeps pumping them up. So as far as we have seen, we have not seen that kind of a damage which is alarming at this point of time.
And to add to it, Marconi, the study data I have shown today are based on our original algorithm we published 2017. But in the meantime, we have a second data set with almost a 1 year follow-up that will be ready in a few months with a very different fluence as the ground level and a way higher fluence. And even there, we do not see any issue with a specific excessive haze. So if you look at it on the basic levels, as Royce has said, it is not the HPMC that will drive these differences. So you don't have to worry about this too much.
And Marconi, can you hear me? I have
yes, great discussion.
What happens is, because we worked on haze using different keratocyte populations, especially during cross-linking, haze is heavily dependent on how many keratocytes are alive, because keratocytes, because of the injury, they change to a myofibroblast and all that factors. So many of these thin corneas, advanced keratocytes, have population of keratocytes is anywhere 50% down. They don't have population. So what I feel is it's more than when you don't have keratocytes, you don't have anything to react. And when you don't need anything to react, they don't become scarring. So that's one of the reasons you see them less reactive, because there's nothing there. And this is something which I've noticed when I've been studying the population.
Well, yeah, I mean, I think you're going to towards a different direction. Yeah, I mean, I think, well, first, I mean, there are two mechanisms of haze after cross-linking. One is related to the differentiation from keratocytes from myofibroblasts, and also we can see that some you go and have apoptosis and disappear, as you put perfectly, but some will start to when they start to repopulate, some will get in touch with the cytosines and differentiate into fibroblasts first, and then later into myofibroblasts. But there's another mechanism that is also related to the extracellular change and associated to the toxic effect of the cross-linking itself. And I think both may actually be affected by HPMC. We have studies showing that when we change from dextran to HPMC, we actually also change the level of reaction to the light. And that change, only changing the vehicle, that change could relate to an increase in cell death. And since we have an increase in cell death, we have a higher trigger for differentiation. That's what I meant. Fantastic. But yeah, it's very nice to see that you guys both are having great results. This is one of the fields that I think we have to put more collective work, try to work together internationally to have, even to move forward and have even more achievements in this regard. This is very, very interesting.
I think what you raised, Marconi, is a very, very important point. I think this is very important for all of us and all the people who are listening, that use of a vehicle, whether dextran or HPMC or a hyperosmolar or isoosmolar drops, can affect the way the cornea heals, and that has an impact on the scarring. I mean, am I right? This is what you're trying to convey? Because this is...
Exactly. I mean, there is difference between scarring and haze. But yeah, that's what I mean. Yeah.
So, Farhad, would you like to comment on this? Because it's very important, because a lot of us in our country, we have no standardization of using the same type of drops. Many people have using different type of drops from different companies who come out different combination. So that means that many times, if you're non-standardized, your comparison of results also becomes completely difficult, because some people say that they're getting fantastic results with one kind of a protocol. Some people don't get it. So do you think that use of drops with different composition has an impact on the outcome of what Marco? It's a fantastic question he asked. I think all of us should be aware of this.
I absolutely agree with Marconi. I think there will be a direct impact on the outcome. Now, at the same time, we wear two hats, right? We were the scientists set, but we all are surgeons primarily that try to find the best output for our patients. Now, I must say that what my personal motivator was using a solution that has neither HPMC nor dextrane, so similar to the interferritic one. I really don't believe that we need 515 different riboflavin solutions that are on the market flooding us. It's so what we have tried to do with Eberhard Spörl, and we had the luck to have Eberhard on board for this for almost 2 years, was to develop a riboflavin solution that you could use for epi-off, for epi-on, for iontophoresis-assisted cross-linking even, and for PAC cross-linking. And this is why we did not include HPMC, and it was not a bad decision at all. As I said, we have further developed our algorithm based on the early data that the Zeiler group has had on endothelial damage threshold levels, and we have adapted the entire algorithm to way higher fluences and have a really good effect now, and an even higher success rate than what I've shown you before. So I must say, in the end, as a surgeon, HPMC yes or no, and wound reaction, this is all nice scientific talk, but in the end, you want to look at the slit lamp and say, this has stopped the disease and it's made my life easier, and it is only one solution, and I don't have to study physics to understand my riboflavin anymore. That was the idea behind it.
And one thing about HPMC-based products, that if you have impurities in them, if the manufacturer has not got you the best quality of HPMC, you will get a very bad reaction. And many times you will even end up in a sterile kind of a reaction. Is not because of riboflavin, because of the HPMC. Because HPMC is, some people, because it has proteins which can create reaction on the cornea, or for a particular person. It's like how you have a penicillin allergy. You can have it on the surface if you're allergic to some components of it. So having so that's one of the reasons many times we get some people behave very aggressively to your same treatment, and the same other patient would probably have not had the same effect.
In fact, Rohit, here I would like to quickly point out, I had raised an issue with transepithelial, epi-on cross-linking in the American Society meeting a couple of times. And then the answer was, we tried to say that it was not as effective or as this thing as epi-off in our hands. And we were using the Peschke transepithelial riboflavin. But then, I think in the American, some of the investigators on Kerenet, they pointed out that their proprietary riboflavin they were using in the US for their FDA trials were very different from what others are using across the world. And that's why they see almost equal efficacy of epi-on as we see with epi-off. So I had to back off and they were not willing to disclose what kind of proprietary epithelial, riboflavin they are using.
So I think basically the take-home point from this discussion is very clear. The type of riboflavin we use, each one of us, makes a huge impact in how the outcome is going to be. So pick up one riboflavin which is used conventionally by most of them, so that at least when something goes wrong, you can have a pooled discussion on it rather than using something where very few people are using. So I would like to move on to my next speaker. I mean, there's going to be a
Can I just ask one question to Dr. Hafezi? Hello.
Yes, go ahead.
Yeah. So here in India, we don't have only riboflavin without either HPMC or dextran. If we were to use your data, is it okay to extrapolate it with, say, HPMC riboflavin, or would you suggest to do some sort of a nomogram correction?
As far as I understood,
because we know that HPMC thickens the cornea a little bit.
As far as I've understood, Professor Shetty has taken our original algorithm and is using it with HPMC riboflavin. So at a given moment, it would be simply interesting to compare our data. On another note, do you have the Rickrolin from SOFT in India?
No.
You don't. Okay, I see. But again, if I compare our data, this would be quite interesting.
Thank you. I'll move on to Dr. Rajesh Fogla, sir. He's got some very innovative ideas of stromal augmentation post in keratoconus. He's presented this in AO and many other conferences. It's a fantastic video-based presentation. Dr. Fogla, sir.
Thank you, Rohit, and good evening, everybody. We have done almost more than 3 hours of presentation and discussion, and we still have a lot of strength and interest in the subject. Now, this presentation is basically some work that I did back in 2016 when we had a grant from ZIMA to do this technique of stromal augmentation using cross-link lenticule. And the concept for this stems from the paper, from the work done by the group from Netherlands, Melis group, where they have published successful outcomes of using Bowman's layer transplantation. However, harvesting the Bowman's layer is not that simple. So we thought, why not use the femtosecond laser to be able to do a procedure where we can augment the corneal thickness using. So just to share you a clinical case, this is the 20-year-old female. She had moderate keratoconus, wearing contact lenses for the past 4 years. She was unable to tolerate contact lens wear in her right eye. Uncorrected vision was 20/100, improving to 20/80. And so examination, she had moderate keratoconus. This is the right eye. You can see that the steepest case was 61 diopters, or 7 diopters of astigmatism. The thinnest point is about 423. So this is an ideal case for doing cross-linking and contact lens wear. Or we looked at the other option where we discussed with her the option of doing a intracorneal ring segments, but she didn't want to have multiple procedures and she wanted to have predictable refractive outcome. And I was not very keen on intervening surgically to do a corneal replacement surgery. And at that point of time, since we were enrolling patients for this study, we did discuss with her about the stromal augmentation technique. And we also proposed that this could be a potentially reversible technique. So she was willing for that. So what basically the procedure entails is we take a donor cornea and we put it on the artificial chamber. And then we remove the entire epithelium, ensure that there is no epithelium left on the surface. Then using the femtosecond laser, we make a 100 micron thickness lenticule, 8 millimeter in diameter, and the edges are 150 degrees. So the anterior diameter is smaller than the posterior diameter. Then we soak the lenticule in riboflavin, HPMC containing riboflavin for about 20 minutes. And then it is placed back on the artificial chamber on the cornea. And then we expose this to do a cross-linking 18 milliwatt for 5 minutes. The objective of doing cross-linking was to basically strengthen the collagen. And at the same time, we know cross-linking kills all the keratocytes as well. So basically, the antigenicity of the tissue would be reduced. So we would have a lesser incidence of stromal rejection. And this tissue also contained the Bowman's layer. So we were trying to see if we could transpose some of the results from what we had seen with the studies from the group from Netherlands. So once the cross-linking is over, we remove the lenticule and then we soak it in antibiotic solution for 5 minutes. And then we go on to the patient's eye under topical anesthesia. We mark the center of the cornea and we use the femtosecond laser to make a pocket 9 millimeter in diameter at about 200 micron depth from the surface. We make 2 pockets, 2 millimeter pocket on one side and a 4 millimeter pocket on the other side. And then using a dissector, we go and open up this stromal pocket that we have created. You can speed up the video a little bit. And then the lenticule is loaded onto something like a Bucine glide. So this is a Macaluso inserter, come with a microforceps, and we grasp the donor lenticule and pull it into the interface, maintaining the orientation where the epithelial or the Bowman layer side is superior and the stromal side is inferior. And then
Dr. Fogler, there's some voice issue. Can you speak again?
Looks like his internet is down.
Okay. Should we go to the next speaker and take his thing later? Dr. Gaurav, should we do that?
Yeah, I think so. Yeah, I think so.
Swami, are you ready? It's a very interesting talk Dr. Swami is going to give about, it's called a sympathetic cross-linking. That means when you do a cross-linking on your right eye, what is happening to your left eye, which is untouched? We are seeing something very interesting phenomena here. So I thought we call it a sympathetic. We borrowed this word from sympathetic ophthalmia. So it's very interesting. And we've been doing this work, trying to notice this for the last few years. Swami will quickly go through it. It's not a big presentation, so we can have a lot of discussion because there's something very interesting. Swami, he's the scientist, immunologist at our Grow Lab. So quickly go into the real meat.
Yes. Good evening, everyone. Thank you, sir. So we are all familiar with collagen cross-linking for keratoconus, and we are aware of the direct effects, that is making the collagens come together and stiffening the cornea, okay? The extended effects has been coming up lately, including that of work of Dr. Hebert Frohel, where he has shown there is a reduction in the immune cells, and also two very recent publications has confirmed that there is a decrease in inflammatory cytokines, okay? So why are we talking about immune cells and inflammatory cytokines is we're absolutely familiar beyond doubt that excess inflammation is driving keratoconus progression. So we should be aware of that, and we wanted to see how it is getting modulated following cross-linking. So I'm going to skip a few slides and get to the chase. So this is one of the classic case example which Dr. Shetty shared, where you can see the right eye was cross-linked. After close to 6 months, you could see an absolute stabilization in the left eye where cross-linking was not done. And this is another classic, another case example where such a case has happened after a year. The left eye was cross-linked and the right eye stabilized, which has not gone through any kind of cross-linking. So we wanted to.
I think we just hold on here. I think if Damien is also here, I think he will be like to ask this question. This first thing you would ask is, was this patient an eye rubber? This patient was not an eye rubber. So it's not that we did one eye and the other one, because when we took this patient up for this procedure, we were very clearly wanted to study those who are non-eye rubbing individuals. The second question I think everybody would want to ask, I'm sure Farad and Gatinal and Gaurav sir, is, was there progression before this? Both eyes, were they showing progression? Both these cases, I mean, this is one of the few, we have close to 24 of these patients now. Both these patients were progressing before we did the cross-linking on both the eyes. That means only thing is we did the cross-linking on the left eye because the patient had more severe disease, and we had given the patient waiting time for 6 months or 3 months, so that we will do the surgery after a few months time. So that means that more or less they did not have eye rubbing and they were progressive by nature, by definition. So I think these two things, I just wanted to clear it from a clinician point of view. Swami, please.
Absolutely. So based with that amount of clinical clarity, Dr. Shetty asked a question whether the inflammation which drives keratoconus progression, has it been altered? So we did tear cytokine profiling and the so-called sympathetic cross-linking eye, as well as the cross-linked eye. And I've summarized, we didn't look at one or two cytokines, we looked at a range of cytokines. In order to keep it very simple, between the pre and the post-op, we did a fold difference so that every eye has been accounted for the change. The green, the C of green, which is C, clearly indicates that these cytokines have reduced in the non-cross-linked eye, and there are very few which has increased. So that was a clear indication that there is something going on beneficial after cross-linking the other eye. So Dr. Shetty asked one question: why does this happen? And the entire ophthalmology community is familiar with this. Sympathetic ophthalmia is already there, and it was always considered as a non-beneficial outcome of one eye getting injured and the other eye getting affected. And the second point, which is often hypothesized or speculated, it is an immune-mediated phenomenon. And once again, Dr. Jerry Niederkorn has also shown a similar thing where in an animal model where one cornea gets triphined and the other eye, the contralateral eye, loses its immune privilege. So the phenomenon exists. But what is unique here is that we have the benefit of the sympathetic phenomenon for the first time following cross-linking. And we have two theories, because we had to think about it to see why is it happening. So we can start with the assumption. The cross-link has happened and steroids are given, and that changes the local phase, the initial phase, where the localized reabsorption, whatever the case of cytokines was there, the feed negative or feed forward happens, gets into the draining lymph nodes, goes to the second phase, and then the lymphatics and the recirculation happens, and leading to a beneficial effect of the contralateral eye. The next theory is a nerve-based. So if you have an inflammation, your sensory nerve endings is going to pick up from the corneal surface, and then you're going to get a motor signal. So when there is going to be a reduction in the sensory stimulation by the reduction in the inflammation in the cross-linked eye, the motor signal goes on because you have the signal comes bilaterally, and there could be a reduce in the inflammation. And this is not new. There is actual evidence about, not for the sympathetic cross-linking, but how nerve sensing of noxious stimuli or inflammatory stimuli can bring about changes in the cytokine profile. With this, I'm going to stop and say there are direct effects and there are extended effects of cross-linking, and we also have a beneficial effect of sympathetic cross-linking, which is emerging, which we will be dissecting. And I'll stop here, sir. Thank you.
So basically, this is the paper which we had submitted to ASCRS. We had basically the experiment was when you're doing the cross-linking, we would collect the tears and other materials from the non-cross-linked eye and serially see how it's changing. And what was very interesting is the non-cross-linked eye would also change in the immune profiling. So it was very interesting where you're not giving them any treatment. I would like to open this for discussion with Farad, if Dr. Marconi is there, and Gatinal. So I mean, there's something very interesting concept which we thought we should share. Because
I have a question. You said the other eye was flattening,
yes.
but by how much?
We ignored any flattening. We ignored anything less than 0.5 diopter because it could vary because of repeatability. We also had we would take anything more than that when we would take 3 readings to see that it was not a repeatability issue. And all the patient had an epithelial remodeling, epithelial profiling to see that it is not related to the epithelium. And it was a true remodeling, true flattening.
From the stroma, you mean?
It looks like I've not done the scans from the Bowman's. Abhijit is working on it, but it looks like it could be. It's definitely not an epithelial change at this point of time.
Yeah, because I would warn you against repeatability. I think half a diopter for keratoconus is not making sense because all the studies I've read, I mean, there are not so many, but the threshold for repeatability, you know, if you do blend out.
Sorry, it's not half a diopter. I'm saying half a diopter and above. So the maximum flattening we have seen is, we saw a patient yesterday with 1.2 diopters.
Yeah, sure, no problem. But if you want to demonstrate that a flattening occurs in a keratoconus patient after whatever you do, it should be, based on the studies I've done and read, about 1.5 diopters, not half a diopter, no, 1.5, because the more irregular the cornea is, the less repeatable instruments do. But now I'm going to speak about my protocol, you know, the Gatinel protocol for keratoconus, which doesn't use riboflavin or UV, but just focuses obsessively on, first, of course, eye rubbing cessation, and second, sleep position modification, because we noticed, and we just published this in Cornea, that sleeping on the stomach or on the side is a very, very significant risk factor for keratoconus. And in some cases, we believe that people had unilateral keratoconus because they slept always on the left side. So we follow our patient regularly because we don't treat them. We just have a very non-surgical approach for that. And what we see is flattening way more than 2-3 diopters without doing anything but changing the sleep position and rubbing cessation. You know, we've done that website, defeatkeratoconus.com, because I bet people would not believe us. So the only reason we made the website is for you to go see case that we have 100 cases. They are not selected. They are very well documented, and you can see that 1 diopter of flattening can be something based on chance or some fluctuations, or sometimes I agree with you, some change in the cornea. But I bet it's a condition linked to epithelial remodeling in some ways, and maybe also the wall page effect that they have when they change the way they sleep. Because, you know, orthokeratology, you take a hard contact lens, you put it, you don't rub, you don't press, and within like a month, you can have flattening by 3-4 diopters, just wearing a passive rigid contact lens. Now, if you have the weight of your head for 7 hours on your cornea, you can expect the cornea to deform very significantly. And once you modify your sleep position, you may expect, like when you remove your hard contact lens for a month, a kind of a change in the cornea topography in the multiple dioptric range. So my point is, it's very difficult to prove that whatever you do is based on a special maneuver, because when you don't do anything but release a cornea from any mechanical stress, you see the same thing that we see in cross-linking and those kind of things, or even other eye cross-linking.
The pressure-induced changes will make a huge impact on how it progresses or how it stabilizes. Farhad, any question, anything on this? Is Dr. Rajesh Pogla ready?
Yeah.
Yes.
I'm ready. I can go back to my screen.
Oh, I think this was very interesting for me to observe. The expression levels, I saw a somefold increase and decrease, but I know that you're experiencing it. So these were all significant changes.
These were case-by-case basis. So I just showed you exact cases. The significance is only when we have an entire cohort done, we would be able to appreciate that. But I would say magnitude-wise, yeah, it's an appreciable. The fold difference is where I had a cutoff 1.2 minus and 1.2 plus were cut off. Those were no differences. So whatever you saw in the green were 1.2 fold lower in absolute concentration.
In a single case to standardize the responses?
I'm sorry, I didn't get you that.
Do you have any means in a single case eyes, if you compare 2 eyes and on the cohort, to standardize the expression levels?
Okay, so we are doing internal comparisons or normalization. That's what we do. So both for the cross-linked eye and the non-cross-linked eye, their pre-op and the post-op will be matched and normalized to continue further. That's the best we can do.
Okay.
And of course, wetting length and protein normalizations of the tear factors will be done. That's about that.
Great, thank you.
We'll move on to Dr. Frogler. He'll start from where he left.
Sorry, I got cut off and I had to restart my Zoom. So this is what the early post-op appearance is. The contact lens is removed after 2 weeks. We give topical steroids for a month in tapering dose, antibiotics for a week, and lubricants for about 3 to 4 months. And this is the preoperative appearance of the, let me just remove this. It's kind of obstructing. Yeah, so I'm not able to see the cursor on my screen. I was just trying to get that. Anyway, so that's the post-lenticule implantation. So you can see that the astigmatism on the cornea now looks a little bit more regular than compared to what it was pre-operative. The corneal thickness has increased by 100 microns. That's the lenticule that we implanted. Pre-operatively, the best corrected visual acuity could be improved to 20/80, and now we can see that the patient could be improved to 20/30. And this is the anterior segment OCT showing you the lenticule that's been implanted at 200 microns there. This patient's topography, everything remains stable. 6 months post-lenticule implantation, now we had a thicker cornea. So we went ahead, did a topography-guided laser ablation, and the maximum depth of ablation was about 65 microns. And we remember we had 200 microns anterior to the lenticule. This is how the eye looked post-ablation. And that's on diffuse slit lamp view. That's the cross-section showing you the lenticule that you can see. So basically on diffuse illumination, you can hardly make out the lenticule. You can just see the slight fibrosis at the edges of the lenticule. For this patient, the best corrected vision improved to 20/20, and he has completed more than almost 2 years of follow-up. And this is the post laser ablation topography. Now you can see that the topography looks almost like a normal eye with much regular astigmatism, and the thinning of the cornea is much more central than what it was earlier when it was displaced inferiorly. And this is the change in topography from pre-lenticule, post-lenticule, and post-ablation. You can see how the central keratometry values are changing. And if you look at the wavefront map, what we see on the series, you can see that's the high order aberration and the coma, which is quite significant. Pre-lenticule, post-lenticule, the coma decreased from 1.89 to 1.34. The RMS, the total aberration is also reduced. And post-topo-guided PRK, you can see that the coma has significantly reduced to only 0.4, and that can explain why the patient's quality of vision has improved. This is the data set of the 12 eyes where we did the implantation. We did not see a significant increase in the best spectacle corrected visual acuity, but the thickness had improved significantly, and none of these patients lost any lines of visual acuity. And if we compare with the post-topo-guided PRK, we find that the post-topo-guided PRK best corrected visual acuity ranged between 6.9 to 6.6. And if we compare the three groups, we can see that the uncorrected visual acuity had a slight improvement from 660 post-topo PRK to 636, but the best spectacle corrected had a significant change going from 618 to 6.9 plus. There was a significant reduction in the steep gait. And if you go down to the high order aberrations, we can see that both the total high order aberrations and the coma had slight reduction following the lenticule and a significant reduction post-topo-guided PRK. So basically what I wanted to present from this was that we can easily prepare the donor lenticule using the femtosecond laser. And it's possible that the cross-linking strengthens the stromal collagen, reduces the antigenicity by removing the keratocytes. And then this also contains the Bowman's layer. You can safely create a femtosecond laser stromal pocket in eyes with keratoconus, despite having a thinning in the center without any complication. Just that in slightly advanced keratoconus, when you make the pocket and you put in the lenticule, when you do a OCT, you find there are slight, it's not planar, it's kind of, there are some folds because the cornea, as you applanate, when you make the pocket, the cornea goes into folds, so the pocket also has a little bit of irregularity. The intrastromal implantation does increase the thickness, but it did not have any adverse impact on the visual acuity, although the patient had an immediate drop in vision post-implantation of the lenticule that took about 4 to 6 weeks to go back to pre-implantation level. The corneal clarity was maintained, no evidence of any stromal rejection after stopping the steroids. And the increase in corneal thickness and the stable topography allowed topo-guided PRK. We had 200 microns of stroma anteriorly, and the overall thickness was also sufficient to do the cross-linking. And after doing the topo-guided PRK in the 5 eyes that we did, they had stable parameters with no evidence of progression. Thank you.
Thank you, sir. Wonderful presentation. First question I want to ask you is the longest follow-up I saw was 36 months.
Correct.
So the topography is stable with no major epithelial change happening out here?
No, on the Scheimpflug tomography, we found that we saw more changes on the posterior curvature than the anterior curvature because we were implanting it at a depth of 200 microns. So the anterior curvature did not show significant changes, but the posterior curvature did show some changes.
The second question I wanted to ask you is, in these cases you did topo-guided treatment, did you use mitomycin?
Yes, we did use mitomycin for only about 20 seconds because we were ablating more than 50 microns, and we knew that if we combine it with cross-linking, the risk of haze would definitely increase. So we did use mitomycin to prevent the haze.
And the third question is, you said that you use the Zima, right?
Correct.
Zima. So it gives you options to make only the side port with the depth, the particular depth. You said that you made a entry wound, right? So
yes, so it's basically like side cuts. You can make these side cuts too, because this was also used for the camera inlay. So they had the planning software for that. And the advantage is the edges, you can angulate it vertical, but we made it maximum 150-degree angulation so that the edges were not standing up vertically. They were sloping with the posterior diameter being larger. And once we did the study and we had positive results, we went back to Zima to try and see if we could extend the study. But by then they were investing more amount of money on the femtocataract. So they did not want, because the market was not there for that. So they did not support the study further.
I think a wonderful study. And the last question I wanted to ask is, the dissection seemed quite easy. Do you think that because the cornea is keratoconic, the dissection at that level, because even though there was no stromal cut by the laser, it was easy?
No, there was a stromal planar cut by the laser. So basically what I was trying to do with my dissector was just to go and open up the pocket, because there are few fibers still attached when you make the pocket. So the pocket was basically made by the laser.
So how did you decide the depth of the...
Sheetal,
Yeah, because we do the... can I ask the question?
Yes, the 200 microns.
Muted, please.
You have to unmute yourself, Sheetal.
She was unmuted, but yeah. You can unmute yourself, Sheetal, before to ask the question.
You are still muted.
Is it fine
Okay,
now?
now you're okay. Yeah.
Yeah. So I just wanted to ask you, how did you decide the depth of the pocket? Like, where do you want to implant the tissue?
Correct. So we, in our mind, when we planned this study, we always thought that we will go back and do a topo-guided PRK to try and normalize the surface. And we know that the epithelium is 50 to 60 microns. That means we have only about 150 microns, 140 microns of stroma left behind. And if we do an ablation of 60, 70 microns, there has to be some residual stroma that will support the lenticule, because if it becomes too thin, then we risk the exposure of that stroma thinning out in future, and then the lenticule getting exposed. So that was the reason. But the other thing that we found out when we started looking at our results is that the deeper you put your lenticule, it has more impact on the posterior curvature than the anterior curvature. Like in the Philly study that you published from your center, you were doing it fairly superficial, putting in the smile lenticules, but then that has a greater impact on the anterior curvature. But the thickness of the lenticule that you place, only about 40, 50 microns, the epithelial remodeling over a period of time will take away the results what you get initially, because the epithelium is slightly thicker. So now what the next step that we want to do is, we want to take a lenticule and do a laser ablation in the center. So it's like having a lenticule which has a thicker periphery and a thinner center, and place it on the apex of the cone with the center. So what will happen is, it will try to give the same profile as what you're trying to do later on with the laser. So you're trying to flatten the apex when you do the laser. So if you try to put in a lenticule where you've already ablated, and even when we want to ablate, we don't want to ablate from the Bowman side. We might flip off the lenticule and ablate it from the stromal side in the center 4 millimeter zone or something to, let's say, about 40 to 50 microns. And then if we put it into the pocket, chances are that later on, the amount of ablation that you need to do a topo-guided correction would be significantly thinner, possibly.
Sure, sir. We planted 100 because we wanted more anterior effect, and because we are modifying in the center, we are punching the lenticule in the center and not planning for a future ablation. So that's the reason why we planned superficial.
Thank you, Dr. Fogla. We have last 3 small talks remaining. We'll move on to Dr. Pooja. She's going to speak on, because a lot of us can't do cross-linking now at this point of time. There are a lot of limitations, a lot of risk, a lot of factors involved in this. So what are the various ways in which, it's a very small presentation of what to do while my patient is waiting for cross-linking during the COVID times. After Dr. Pooja, we'll have Dr. Farad, and then I will sum it up, and we have just 3 small presentations remaining. Dr. Pooja, over to you.
Thank you, sir. So at the outset, I have no financial disclosures, but as sir mentioned, a lot of us cannot do cross-linking. There are many issues. Even our patients can't come to us a lot of times because they are staying somewhere in the periphery, and right now they are unable to travel. So, So what can we do while we are waiting for the cross-linking? So our group has already published in the past that there is increased inflammation in keratoconus, and with increased grades of keratoconus also, the inflammation keeps on increasing, and it differs from cone to periphery. So it is now well established that inflammation can lead to keratoconus and progression. Also, another thing what our group has studied was that, when you have patients for 2 visits, some of the patients are stable over 2 visits, and some of the patients, like over 2 visits or minimum 6 months or above, they tend to progress. So what we did was we did the TR analysis over the first visit and the second visit. We divided them into 2 groups, the stable and progressing. And what we found was that the progressing group had, this group had higher amount of inflammation and other inflammatory markers present in them. And that was statistically significant from the ones which were stable. So now it was well established that if you have inflammation present in your eyes or in the patient's eye, there are higher chances of them going into progression than the ones who do not have inflammation present. So based on this knowledge, how can we take this into clinic in this point of time in COVID times? So I'm just going to be saying that these are the molecules which mentioned in the stable and progression group, and I've just labeled it for today as the wanted molecules or the wanted inflammatory cytokines for our purpose for this presentation. So my talk is going to be divided into 4 parts. The first part is going to be medical treatment and the IG levels, the eye rubbing. So a simple algorithm, if you have eye rubbing, it can lead to higher liberation of inflammatory factors, which will lead to decrease in LOX and collagen levels, because there's higher MMP9 levels, and higher MMP9 or inflammatory markers can reduce your LOX and collagen levels, which in turn can lead to your keratoconus disease. We all know about this, so not to go in depth. So our group led by Dr. Rohit sir and Sharon ma'am published this work on what is the relevance of eye rubbing. A lot of times you get these patients who do not have any active eye allergies or a past history of eye allergies or any active systemic allergies. Still, these keratoconic patients have a tendency of rubbing their eyes. So what is making them rub these eyes? And also what happens whenever there is high levels of IgE? So we did some studies on relevance of serum Ig levels and its impact on keratoconus. What happened, and we found that this group had higher Ig levels. What happens here is when patients rub and when there is high levels of Ig, there is release of itch mediators and inflammatory molecules, which in turn leads to dysregulation of LOX and collagen. So, and this is a very simple algorithm of how to go about the treatment on them, and I'll discuss the same in the next slide. So if we can treat this eye rubbing, if we can stop this eye rubbing for the patients who do not have any active eye allergies also, probably we can halt the progression or delay the progression and save the patient from a cross-linking procedure. So what we do in our clinics is we follow this simple algorithm. We do a serum Ig level test based on the Ig levels. If they're lower, we just continue with anti-inflammatory agents for longer duration, even if there's no cross-linking here. But if the Ig levels are more than 300, we are referring them to an immunologist. We are getting their opinion done. We are doing a patch test to detect the allergens, and then they get the treatment for desensitization and avoidance of allergens. And meanwhile, they're awaiting cross-linking. You keep them on topical anti-inflammatory agents. So now what are the anti-inflammatory agents? What are the different options we have? One of, yes, we have published this work in past, that whenever MMP9 can be halted, or the effect of MMP9 can be inhibited by cyclosporin. When you treat them post 6 months, there is good amount of stabilization which we note. So with cyclosporin, the wanted molecules which I discussed in the beginning, we can halt them here. The second thing is, this is work done on corneal epithelial cell lines, and we have started using on our patients as well. Trehalose helps in augmenting the autophagy, which mitigates stress, and with the stress which induces inflammation. With using trehalose, we can target this MMP9 molecule, and also it will help in reducing the inflammation. So with these two drugs, cyclosporin and trehalose, we can reduce the inflammation and delay the progression. Now the next question would come is, we cannot use trehalose or cyclosporin for all the patients. So how do we go about it? If the patients have any active allergy, avoid using trehalose because it's a sugar molecule. After this talk, we can discuss this with the experts and the panelists here. But if the patient is non-allergic, you can use trehalose in combination with cyclosporin, depending on the risk of progression. Now, next comes the vitamin D. We all know that vitamin D has a role in a lot of pro-inflammatory factors, nociceptive factors, and other factors. Our group has also published this work where we in dry, this is a dry eye cohort, but we have published this, that patients with evaporative dry eye disease and their association of vitamin D and with this inflammatory molecule. So we know that patients with low vitamin D have a correlation with this inflammatory molecule, suggesting that if you have a low vitamin D, then there are higher chances of this inflammatory markers being present. Now, why is it so? A lot of us will say that most of the patients in India have low vitamin D. Sometimes patients have low vitamin D, but they don't have any symptoms. Patients have more vitamin D, even then they have symptoms. So why is it that? We need to understand it's just not about the serum vitamin D levels. It is about that we need to understand that in the epithelium, there are vitamin, or in other tissues of the body also, there are vitamin D receptors present. Now, what are these vitamin D receptors? Vitamin D receptors are nothing but they are present in the nucleus of your cell. Your vitamin D molecules need to go there and get attached to these vitamin D receptors for its better effect. So if your body has low vitamin D receptors, how much ever vitamin D levels you have, it's not going to help. So basically it is about the vitamin D receptors in addition to your serum vitamin D levels. And this is a very interesting work. It's right now in process, where we have shown that with different grades of keratoconus, this is the work on receptors. This is not serum vitamin D levels, but the receptors. If you can see here that the cone and the periphery, the cone has lower amount of vitamin D receptors in comparison to the periphery, and also with increasing grades of keratoconus, the vitamin D receptors are reducing. And vitamin D, yes, natural and endogenous, and it is an natural endogenous anti-inflammatory regulator in the cells, and it brings about this effect by binding it to the vitamin D receptor. So if the vitamin D receptor is low, then the good effect of the vitamin D in reducing inflammation will not happen. So this is one of the important take-home point from this thing. So we need to treat vitamin D and this thing, and it also affects the corneal epithelial barrier function. Now, how do we take this? Do we have any additional treatment here? This is just our hypothesis and based from our dry eye work. We have done this work where we have seen the tear cytokine levels, inflammatory cytokine levels before and after thermal pulsation therapy. I have no financial interests here. And we did find that the inflammatory markers did come down after LipiFlow treatment. So if you see here that these are the wanted molecules I showed in the beginning, and the IL-8, IP-10 levels, which were higher in the progressing data, were also, when you do a LipiFlow treatment, they were coming down. So probably if we can do one of these therapies for our patients while they're awaiting cross-linking, we can target this inflammatory markers and probably delay the progression. The same if you don't have go to thermal pulsation therapy, the light modulation therapy, will it help? Yes, the similar data on the similar inflammatory cytokines were seen to lower down post light modulation therapy as well. So probably we can do one of this therapy to reduce the inflammation in the eye so that the patient's effect of the drops and all will be better, and we can delay the progression. The last is, this is also subject to this thing, the role of micronutrients. Now we all know lysyl oxidase has an effect in keratoconus and cross-linking outcomes. So what is this lysyl oxidase? It is nothing but it has a role, it is a copper-based enzyme. So if you can use one of the micronutrients, no financial interests here, which has copper-based, which is a copper-based micronutrient, then also probably we can help our patients. So just to summarize, for a keratoconic patient, just check the allergy levels, serum Ig levels, vitamin D levels, and based on that, we can categorize them into 3 categories: low, medium, and high. Low, you can low in absence of any allergic eye diseases, we can give a Trehalose eye drops. If they have a medium risk of progression, then you can give a combination of Trehalose and cyclosporin drops. But if they have a high risk of progression, you can probably add it up with a thermal or a light pulse, light-based therapy. So we, just in the pre and the post-COVID era, we just need to shift our gears on how we treat our patients, and it will definitely help them. These are a lot of hypotheses, so it's open to discussion and by the panel and the experts here. Thank you.
The take-home point from this is that we really don't know when we are going to do cross-linking. So whatever you have in your domain, try to use it to reduce the progression. One of the things is, even for an eye rubbing point of view, there's a lot of good thoughts about reducing the eye rubbing through one of your LipiFlow or one of the iLight or EI type of models, which can reduce the molecules which can actually trigger off a change. So these are all extraordinary circumstances. So our response has to be extraordinary here. We have to make sure that they don't progress, because we don't know when we are going to cross-link them. And because of staying indoor, using a lot of hand sanitizers and multiple stuff, there's already a tremendous amount of inflammation already created on the ocular surface. And this could one of the reasons potentially be one of the reasons why they could progress fast. Thank you, Dr. Pooja. We have the last 2 presentation. Dr. Farad, are you ready with your talk? You have to unmute yourself, please.
With pleasure. Let me just briefly switch the screens. Yeah. So can you all hear me and see the slide?
Yes, please. Perfect.
So this was very interesting, and certainly all the induced changes due to eye rubbing in a living tissue is what we should look at. What we have done in a first instance, we have looked at the impact of repetitive eye rubbing on corneal biomechanics. These are my financial interests for this investigation. Now let's just put the grounds to why we were so interested in looking into eye rubbing. I think there was a lot of hype created and a lot of attention created in the last 2 years around eye rubbing. But what we need is more and more substance around it to better understand what does this mean to me as a clinician surgeon. Well, first of all, we know that keratoconus can be very aggressive, certainly very aggressive in children, and the natural rate of progression is quite high. Second, we know that keratoconus is not really a rare disease anymore. We have reports that place keratoconus in a range that is anything but rare. So the disease can be aggressive. It is more frequent than our textbook knowledge would suggest. And the third thing is that if you look at the bundled knowledge that is published, I would say that the treatment is relatively safe. So taking this all together, myself and many of my colleagues would say that, especially when looking at young patients, pediatric patients, that the cone is aggressive in this age range, and the procedure that can be performed is a safe one, especially under the context of more than 2,000 PubMed entries. So this is what we know now that brings many surgeons to the fact that let's cross-link corneas immediately if we see a clear cone, even in a very young patient. And there are 2 other opinions about this. So my opinion and that of, I think, many others is treat immediately. Others say, no, wait until progression. Why? Because you have other factors that play into it. You have genetic factors, you have atopia, and you have eye rubbing. So this is the second subset of colleagues that says, if I see a child with a clear cone, I would not treat, but I would follow closely and then treat by cross-linking. So both of these approaches would use cross-linking. Then there is a third opinion that says not necessary. No rub, no cone. So if you stop rubbing, which is the most important factor, then you shouldn't need cross-linking. So these are the three opinions. Now, if we look at these opinions, my personal assessment for now is I go with the treat immediately. I do not go with the do not treat, because in my eyes, it is not really, this question has not really been answered yet. Is eye rubbing really the cause, or is it rather a trigger or a catalyst? Let me show you this simple video that I've already shown last year at CSCRS, because what we are in need now is less observation. We need observations that lead to hypothesis and to actual outcome. We need data, because everything we've been talking about on the right-hand side, about the do not treat side, is not solid enough for me to understand the opinion. On the left-hand side, the green checkbox, as I said, there are more than 2,000 published papers on it. If you look into anything that has been published on eye rubbing, it is mostly case reports, case series, and correlations. This is nice to have, good to have, but it's not enough for me to go behind this opinion. So, in other words, is eye rubbing the cause or the catalyst? If this gentleman is the eye rubber, then some people believe that when you stop the stimulus, the disease might stop. This is what I think. I think that eye rubbing is a catalyst, and if it's stopped in early stages, then you don't need cross-linking. Might be, and this is, I think, also the opinion of those who say no rub, no cone. Okay, you stop the stimulus and the disease stabilizes. But what I believe is that eye rubbing is rather this here. It is a trigger and a catalyst, and once you go over a point of no return, then there's no sense in stopping the trigger. The disease starts taking its own course and goes wherever it wants to go, whether you rub or not. So what we wanted to know is, what is the real impact? My current assessment is stop eye rubbing. Yes, I tell this to every patient I see because it makes sense to me, even though I don't have a lot of clinical data around it, but I tell them stop eye rubbing. But I don't tell them stop eye rubbing. I will never need cross-linking because your cone will be okay for now. I do not really see this point. So what we have done was a two-phase study. In the first phase, very simple, straightforward. We just looked in a few dozen keratoconus patients, what is the force these patients use in their clinical rubbing? That was very easy to do, and we found several forces. The strongest force with the knuckles. So this was step one. Why did we do step one? We did step one to determine the maximal force we need to translate into our eye rubbing model. This is Mr. Lips. Mr. Lips is a retired mechanical engineer, and he repairs steamboat engines in his free time now. So he's used to find unusual approaches to strange ideas. So we came up to him and said, we need a machine that creates a vacuum, that holds an eye, that has a simulated finger with the right consistency, and that can rub through a closed lid using very precise ranges of newtons. This is what we have been doing now for a few months. And the abstract has just been submitted to the AAO and ESCRS. I will not share all the details, but the study is ready to be submitted. What we have done is we have simulated with the high force, like similar to the knuckle force, a full year of daily eye rubbing, multiple times a day. So thousands and thousands of eye rubs on this cornea. And then we took out the cornea and did stress strain measurements. And we didn't find any, we didn't find any significance to the controls, to the no rub controls. And these were thousands of heavy rubs. So of course this has a limitation. This study has a limitation. It's an ex vivo model that does not take into account the secondary induced changes in the inflammatory markers, upregulation of inflammatory genes with all the related secondary effects to it. But the sheer eye rubbing force didn't do anything, at least within the range that we explored. And this machine was running many hours a day. So in conclusion, I will still treat children immediately, and I will still tell my children and any patient to stop eye rubbing, but I firmly do not believe that stopping eye rubbing is the only solution.
Wonderful, wonderful talk. Is Gatinal still here? If it's, I think he said he had to leave. So you believe that the eye rubbing is...
Yes,
Damien is there.
I'm here. So I don't know if are you hearing me?
Yes.
Yeah.
Oh, okay. Yes. So yeah, I know and I'm glad we resumed this now worldwide famous kind of debate with my friend Farad. I agree with some of aspects, but the point which I want to emphasize on is that you can be right in saying that maybe cone progresses without rubbing. The point which is most important is that, to me, there's enough evidence based on logical reasoning and the analysis of the literature to believe that cone will not start if you don't rub. That's my point. And why that? Because it's just enough. You can go to the literature and see how many observations have been published on people who had nothing and stopped to rub their eye, one eye, for example, and developed keratoconus on one eye, on this eye. And so it shows simply that you can trigger keratoconus just by eye rubbing. And to me, eye rubbing is not the risk factor, it's the cause. In all my observation, when people have highly asymmetrical keratoconus, they have that because they rub one eye more than the other eye. And when they have a unilateral proven over time keratoconus, the only difference is that they rub that eye as well and not the other one. So I think I should not be proven wrong. I think everyone who has a little sense of logic, to me, should try to prove wrong, as Farad is doing, that that keratoconus can be caused without any mechanical triggering. And I take the other very well explored disease, which is always the Marfan syndrome, because most people on Earth address keratoconus like a soft cornea to start with, due to many possible causes, from molecular to biological to immunologic pathways, etc., without eye rubbing being there in the place. And that would make the cornea soft. And then, because it's soft, you need to make it stiffer to prevent keratoconus to progress. I would buy this if just people with Marfan syndrome, which is the hallmark of the soft tissue disease, would exhibit keratoconus corneas, but they don't exhibit corneas. They have a true ectasia, to me. Marfan syndrome patient, thin but flat corneas, because when you have a soft cornea and you don't exert a focal trauma on it, then the cornea distorts and flattens. You know, it's so, to me, striking that keratoconus being focal, and that's been proven by discrete biomechanical analysis on the cornea, like Brouillan, right? So the cornea is focally weakened. It's more focally weakened in the place where you rub the most. People with unilateral keratoconus sleep on one eye and rub that eye. So you have many mechanical things. And eye rubbing is the only risk factor, so-called risk factor, which is directly impinging on the cornea. I would not call this a risk factor when it's directly something which in itself, and it's been published in many examples, can trigger cone. So we can discuss that eye rubbing is universally treating the cone, but we all know that it is enough to trigger a cone. I believe it's a universal mechanism, but you may disagree with me. I agree with that, but you have to convince me because I've never been convinced, and I would like to be proven wrong, but everything I see in meetings is always the same thing. It's not really making this mechanical hypothesis going away. And yes, we can discuss it.
Farhad, a quick comment on this, and then we will move forward to the last bit, the last
one. With pleasure. I think what is important for the entire audience to realize that if Damien and I talk together not as scientists but as clinicians, I think we both agree eye rubbing is not a good thing to do. So even if we have now controversies on whether it's a cause or just a trigger, the effect not to eye rub, we both agree upon. I think where we differ, just to summarize it, you, Damien, say that once you stop the rubbing, you do not need other measures to take care of the patient clinically. Specifically, you do not need cross-linking. And I do believe that if you pass a point of no return, you will dissociate the trigger from the disease progression, and you will still have disease progression even if the trigger is gone. This is, I think, the main difference that you and I have, and hopefully we will have some more data in the future to clarify this.
Yeah, but just one question. I believe that if in a hypothetical world, people would stop rubbing their eye, there would be no keratoconus anymore. That's my point. Maybe there's like a threshold beyond which, by the inflammation that is there for the rubbing, you can probably have collagenesis still going. But it's like a late stage where the disease goes on, I think. For most, like 95% of keratoconus, you can stop it. And and if I would be wrong, at least in my practice, I would be in jail for many times because I have patients with cross-linking prescription for who I explain what I'm believing the right thing to do, and they don't progress. If they would, I would be in jail. My opinion is public, and in fact, the other way it happens, people say, "Thank you, Dr. Gattinel. I saved money, I saved some possible risks." And my keratoconus is stable, and it's not a genetic disease I will give to my children.
Thank you, Gattinel.
Just one last thing. I agree with Damien, and I know the time is running away. But on the other hand, I've seen so many patients without any sign of ever having rubbed their eye with a clear cone.
Of course,
we have had this discussion.
Drink and they don't say they're drinking. But some people really don't know they are rubbing until they wear a patch.
We learned from you. We asked them specifically. So yes, people without any sign of ever rubbing the eyes displaying a cone. But I think this turns around. What I'm happy is we have one more element in this debate to see.
Last words from me. I will be convinced when someone comes to me and demonstrate to me that the soft tissue they deform like a cornea without any mechanical strength at some point. That's what people need to demonstrate, and that has not been demonstrated, and it has even been counter-demonstrated by the Marfan case, Marfan paradox, as I call it. So once you have explained to me how a cornea can deform without any local focal damage, I will be revising my point, but so far,
I think Farhad is a great researcher. I think next time he will get somebody to design something to prove this to all of us.
Because I would love to do cross-linking, no problem. It would be another. Surgeons like to do something, but I cannot do something I'm not convinced about.
Thank you, Gattinel. I have a last presentation, just 4 slides, but it's very interesting and important for all of us. Can you load my presentation? It's about epigenetic of refractive surgery. Basically, this is Arka is here. I just want his help. Perfect. So what we did was the research question. I'll be very brief and very fast. The research question we wanted to ask is, when we do a refractive surgeries and we get different outcomes, can there be an epigenetic changes between, say, a smile versus LASIK surgery? Because we assume that if complication happens, for example, when you end up in an ectasia, and these are how the collagens are. This is the lysyl oxidase which binds them, which we already described. What we did was this whole experiment involved ex vivo eyeballs. When we created from the donor globes, we created a femtosecond LASIK and a smile. And Arka can quickly describe this, what we did, so that I'll go into what we actually found from this. Basically, we wanted to know how the healing responses were between the LASIK and the smile, and whether these healing responses, genetically healing responses, were actually related to the complications we get. Quickly, Arka, because we are in the last leg of this.
So essentially, what we were trying to study is that when you have a refractive surgery induced trauma in your cornea, how do the gene expression patterns within the keratocytes there change over time? So we took two different surgeries, and we essentially, this slide image you see in the middle, that's a CPG island array across the whole genome. So we took these donor globes, treated them, kept them for either 3 days or for 2 weeks, and then extracted the DNA from them and hybridized it to the array and then analyzed it. So on the right, you see some volcano plots and differential display plots for the data that we got. There's thousands of data points. So essentially, the idea was to see what's the immediate response, as well as a 2 week later, a slightly delayed response, and whether the two surgeries have differences. So it turns out that there are. So there is. It seems that the epigenetic response, so CPG islands that are methylated or not methylated are more at 2 weeks rather than at 3 days, showing that there is an ongoing process and the epigenetic response is something very real. So therefore also brings in the idea of how epigenetic modulators can be used to get better outcomes. So the key things that we found was that obviously there were transcriptional regulators that control the fibrotic response. Those were obviously found to change. But we found a bunch of very new genes and very interesting genes. So one of the things that we found was that so the profibrotic response is more of an EMT, type 2 EMT response. We call it epithelial to mesenchymal response. In case of smile, we found a few genes that were actually doing MET, which is the opposite of EMT. So we still don't know what this all means. And some of these genes were common between the two surgeries and some weren't. So the interesting thing was that the profibrotic response and the immunological responses that we found were of a different quality between these two surgeries. So we still need to validate these things and figure out what it means in the longer time.
So can you hear me now?
Yeah, I was telling them about it. So
yeah, I understand. I mean, I was listening. So basically, to sum up on this part, your ectasia, what you get is completely different from smile and LASIK. So what we used to see.
I mean, what is interesting is what we could have done if we had this knowledge before was in our smile ectasia patients, we could have checked for MET genes. I mean, we wouldn't have thought about it before. I mean, that's a new discovery. So we don't know exactly, but if in those smile ectasia patients we had looked for these things, then some of these hypotheses could have been proven.
So basically, to sum up on this part, is very important for all of us that both the procedures behave completely different as wound healing is concerned. So if you get a smile ectasia in a healthy, good-looking, normal eye, it could be that some genetic thing is completely different there compared to LASIK. So that's something which is a very big take-home point from this. And we come to the end of this session. I would like the panelists to say something or before we sum it up. Dr. Rishi?
I thoroughly enjoyed this session. I think this was the best 4 hours I've had during the lockdown. Totally enjoyed, and it was wonderful to listen to speakers like Dr. Hafezi and Dr. Kameng and Dr. Santiago. Wonderful. Thank you for making me part of this. Lot of learning.
Ritika, any take-home points? If you give us one take-home point from this, so that it'll help the audience also. Whoever, I mean, if people are not listening today, they're all going to listen to the recording version tomorrow.
So,
Rohit, one point I wanted to make was that
yes, sir.
When you are studying the response of, doing treatment in one eye and looking at the behavior of the fellow eye, maybe you can also look at a subset of patients who undergo intracorneal rings. Because I have observed in my clinical practice that there have been patients who have undergone intracorneal rings, and after that they were supposed to return back for the corneal cross-linking. And for some reason, these patients fail to turn up, and when I see them 3 to 5 years later, and I'm surprised to find that the keratoconus has remained stable throughout this period of time. So, intracorneal rings and post-intracorneal rings progression is something that we need to investigate further, because I believe that the impact of maybe the pressure of the intracorneal segments that you put in the stroma, what impact it has on the corneal nerves, or whether it changes the corneal sensation level, or whether it has a change in the composition of the tear film, or because of change in the surface contour, is something we don't have, because intracorneal rings are not performed routinely by everyone, and whatever clinical result data we have is very, very variable in terms of visual outcome. And so again, the timing of cross-linking along with the rings is also not very clear. Some people do it before, some do it combined, some prefer to do it later. So I think if we look at patients who have only undergone intracorneal ring segments for keratoconus, and if you have some of these patients who don't undergo cross-linking, to look at is there any change in the composition of tears before and after the rings, or any other parameter that you would like to study.
We'll do it, sir. In fact, you're very right. We started rings before cross-linking was in vogue. And a lot of those patients where we put just the rings are still holding on, when I've not done a cross-linking for them. Absolutely right.
I happened to see a patient from Africa who's 19 years old, who presented to me when he was 19. Both eyes I did rings, and then he disappeared. And I saw him 9 years later, and I was amazed to find that he's maintaining pretty good vision, exactly the same topography, and there has been no progression at all. And he was at an age group where you would feel them they are at risk for progression. And it's not like it was very early keratoconus. He had moderate keratoconus, and he's still doing pretty well.
I just have a point to make there. There's a paper by Dr. Cynthia that explains this very well. When you implant intracorneal ring segments, you actually redistribute the biomechanical stress, and that breaks the vicious circle of progression. So there are two ways to break the vicious circle, and ICRS does have a role in stopping progression, and we've been doing it for a long time. And there's another paper in BGO which really does a very good case control study between simultaneous and sequential. And I think there are some merits to the simultaneous treatment, and that's what we're being following.
But the problem is that whatever you see results in one study, it's not been replicated in another one. So you don't know whether as a uniform, whether it's going to work, or whether it works.
Yeah, but Intax has never been pure mathematics.
I think the time has come where, like Farhad was mentioning, that sometimes there are a lot of small series, small case reports where you find, but you cannot really put forward a scientific basis for what's exactly happening. And if you have the resources now to carry out studies and look at the biomechanics and use AI to try and figure out, maybe we should be in a position where, by studying the biomechanical properties of the cornea and looking at the topography and feeding that into a neural network, we should be able to have some sort of prediction that if this eye undergoes a intracorneal ring, what is the kind of expected response that you may have in the future.
Yes,
I think we should probably pull all our cases where we have done only the Intacs and then figure out what was really different in them and build in an AI model, which will probably help us. Dr. Rishi, your take-home points from this one point.
I think one point which I really probably stuck with me is the point of sympathetic cross-linking. I think that's a very valid and real thing, because I've also seen it in my clinic, and I didn't really think about it in this way. And I think I'll go back and look at it more closely in the future.
Vogla, sir, your take-home point for the audience?
I think there are plenty of take-home points. I think you
diplomatic answer.
No.
There are so many.
Just have one point. I think the biggest point is what Parad mentioned about thinner corneas, because sometimes we see thin corneas and we say, oh, you can't have cross-linking, and we then look at the surgical intervention option for them. But like if we try and follow the nomograms, what Parad is proposing, I think a lot of these patients, we can still give them a trial of trying to cross-link and see if that works. And if it doesn't work, we don't lose anything. We can always go back and do the surgery. But if it works, especially patients like keratoglobus, I would be very interested to look at your the parameters that you use for keratoglobus, because some of these extreme ectasia, even doing a surgery is sometimes very challenging. So I think that is very important. And the other take-home point is that we should have a uniform riboflavin that everybody uses the same, rather than having a different wide variety of formulations, which again gives rise to variation in results. So I think these are things that we need to implement in our practice.
One more point for me would be the ray tracing ablation. That would be interesting to see when it comes to us.
Dr. Gaurav is here, please.
Yeah. I mean, there's so many take-home messages that I can't even list them. But I mean, even if all of us give one, we'll still not be able to list them. For me, I think one very exciting thing which looks very promising is what Farhad said and Dr. Cummings talked about. Possibility of doing deep ablations on the surface without mitomycin. That looks so promising. I don't know whether it'll still be possible in our scenario, but that remains to be seen. And then no mitomycin and like ablations of 120 microns, especially using SmartSurf or Streamlight. I forgot to ask Arthur whether he sees the same thing with Streamlight as Dr. Hafezi sees with SmartSurf, as far as avoiding mitomycin or doing those deep ablations are concerned. So it would be worth considering, and that sounds very, very exciting to me. Of course, so many other things. I'll leave the others for the rest. But
so anybody else in the group who's still around who can just give the take-home point?
Rushad is there. Sheetal is there. Yes.
Rushad. Sheetal, yes, Sheetal.
So overall, it was a very nice and very informative and very insightful session, I would say. This is my first NN session which I have actually attended full, and I must say that it kept the interest on until the end, and the talks were very, very informative, and a lot of new concepts I learned today. I especially like the Dr. Gatinal's talk on the new method of analyzing the abrasions. So I think that would be something which could be a game changer in the field of refractive surgery and also cataract surgery. And I also liked the epigenetics concept which was discussed in the end. So understanding the healing patterns of different refractive surgeries would also improve our understanding about how the expected outcomes would be. So thank you so much for inviting me, and it was a very nice session. Thank you.
Rushad?
Quick one. I'm not going to say much more about the session, but I think Sheetal just took my point. I was talking about Dr. Gatinal's way of studying the Zernike, not using Zernike polynomials. I didn't have any idea how it affects defocus. So that was something new that I learned today. And of course, the ray tracing method for ablation sounds quite interesting.
Sharon?
I think other than, of course, everyone's talked about the fabulous talks we've had, but definitely a point to be mentioned are all the cases that were there between, which are all very, very interesting, small capsules of take-home points from Sheetal's, how to dissect, to even Dr. Vogla's beautiful demonstration of the insertion of the lenticule, which has been cross-linked. So very, very interesting cases with a lot of take-home points. Yeah.
Anybody else has to add anything before we end?
I think, Rohit, this will be a gold mine. This session is probably going to go a long way. it's going to be used for teaching so many people in refractive surgery that it has a gold mine of information, some of the best speakers, some of the best information. And I think, one of the longest sessions, I forwarded it to my fellows and few other people whom I thought that, they just cannot do without going through this. So congratulations for arranging one of the most exciting sessions in refractive surgery that I've attended for a long time. And, great job. Congratulations to everybody for, all you said. Thanks.
Kudos.
Just one small comment from Switzerland. I just wanted to... Hello?
Yes.
Yes, sir. Please tell me.
Thank you very much again for the invitation. I also enjoyed it a lot. And looking at the bigger picture, we spoke a lot about how to remodel the cornea with the laser, how to strengthen the cornea, what the implications are. I specifically enjoyed Rajesh Fogla's talk because he brought the future of additive technology into the whole thing. And I strongly believe that in a few years, we will have many more of these talks over the span of 4 hours in such a format that add technology, that add tissue, and then remodel the entire cornea by additive technologies.
Thank you. Marconi, are you there? I think he's down. Anyway, thank you all. I thank all the panelists, speakers, and each and everyone for helping us to make this program a success. And hopefully we'll see you in better times where we can meet and greet in physical contact. Thank you.
Thank you.
Thank you. Good night.
Bye-bye. Thanks, everyone. See
Wonderful.
You.
And
Wonderful. Congratulations.
I'd like to say thanks to Dr. Rohit Shetty, Dr. Farrar, and Dr. Damian Gatnell, and all the others because they have come here from international. They have joined us. Thank you very much, Doctor. And special thanks to Dr. Arthur as well as Dr. Santiago. He had a lot of difficulty in joining us, but then finally made it. That's the thing. Thanks.
And thanks to Micro. Yeah.
Thank you, Microvision, and especially Microvision is a very, very supportive company based out of Bangalore. They make a lot of unique products, and Ashok has been really helping a lot in academics. So thank you, Ashok and Microvision, for this great opportunity. Thank you. Good night.
Good night, everyone.
Good night. Yes.
Bye.
Good night.
Good night.